Welcome back, everyone. We are here for day 3 of the Certified Cloud Security Professional Bootcamp that we're doing for you from Go Cloud Careers. My name is Mike Gibbs. I'm your friendly host, if you will. I'll be doing much of the presentation during this discussion. I've been an IT architect now for about 25 years, network architect, security architect, enterprise architect, all of it. And I'm joined here by my Chief Technology Officer, Mark Milovanovic, who is a network architect and who's got a lot of experience as a network engineer as well. So he's going to bring a lot of extra technical flair to us if there's any desires today. He also is extremely knowledgeable in the world of cybersecurity, far more than he'll even admit. So we're going to be here for day 3 of this certification bootcamp. And as you may have noticed by now, this is a very architecture-oriented kind of certification. It's very conceptual. It's not, hands-on engineering-oriented because it's all about getting you to think about the kinds of things we need to think about at that policy level, at that security architect level, whether it be data, demilitarized zones, how are we going to design it, what do we need to think about it? And that's why so many of these things will bring as many questions as they actually do answers. So kind of hope that actually helps explain why we've been doing it. So we've been having some fun on data. And of course, we're going to talk more about securing data today. But before we begin, I want to remind people of a few things. First thing I want to remind you of is that we have our completely free How to Become an Architect webinar on Thursday. And we do this most Thursdays, but we have one coming up this Thursday. And we'll go over the architect role, whether that's a cloud architect, security architect, network architect. They're fairly similar. There's some variations, and we'll happily talk about that if you desire for us to. But we'll talk about what we do as architects, what hiring managers are looking for in architects, the skills that you need to possess to be an architect and get hired as an architect. And it's all free, and then we'll answer your questions for upwards of an hour and a half, because we really want to help you. We'll answer any kind of career question you may have, whether it's related to what we do, whether it's related to your goals. It doesn't matter. We make use of this time on Zoom so you can ask face-to-face questions. Also, along with this program, my team has written a book for you to help you pass that CCSP exam. I think it's about 450 pages, just a little shy of that, of notes, cheat sheets, if you will, that are really going to help you pass that exam. So please make sure you get a copy of them. They're free, and all you need to do is just sign up for them. The link is in the description below, and I will also have my team drop it in the chat box for you right now. Mark, you want to say a few words, and then we'll begin?
Definitely. First of all, welcome everybody. It's always excited to see such a nice international turnout that we have. I see all of you already jumping on a little bit on the bandwagon, giving us the hashtag CCSP. We like to do that to start off the session with some high energy, and as well as see that everybody's actually alert and being capable of being here. Besides of that, we have fantastic content planned for today. We're going to go into data security a little bit more. So we're going to have some of those questions that you guys were asking us during the first 2 days answered, and I hope everybody enjoys it. Feel free, of course, to put your questions into the chat box. Whichever questions you might have, we'll do our very best to answer them, of course. And aside from that, let's have fun.
That's the key. Let's try to make this learning fun. So if you've got questions on the learning, we are so happy to do anything we can to actually help you. So actually, before we begin, give us a hashtag CCSP. I come from healthcare where we have to know the person's oriented towards the person, place, or time. We call that awake, alert, and oriented. So it's just me to check that everybody's there because I can't see you, although sometimes I really wish we were in the same room. So let's briefly talk about cloud data security. So we have to begin with the data lifecycle, especially of our lifecycle of data on the cloud. So at some point, the data has to be created. And then typically the data is used. And then it's typically stored. And then it's typically shared. And at some point it's archived where you don't use it anymore. And then it typically gets destroyed. So kind of think about that as the cloud data lifecycle. So the data in the cloud is going to have those same security requirements as we would need on premises. And whether we're going through a creation stage or a storage stage or a use phase or a sharing phase of the data, archiving or even destruction, we have to have security at every part. So secure implementation will vary based upon the data center or the cloud, even though the environments are fairly similar. So the first part of data creation in this data lifecycle is the create phase. So when the data is created, where's it going to be? Where are you going to store it? If you store it on premise, it's on premise, and you've got a lot of control of that data on premise. That data doesn't even need to be exposed to the internet by any way, shapes, or form, and you can really control that data and where it is. You can do some of that on the cloud, actually, a lot of that, but you can have much more control of what you can do in your data center. But are you storing it in the data center? Or are you storing your data in the cloud? Maybe you're not storing it in either one of those places, and you've got an off-center or co-location facility where you actually have servers that actually have a lot of your data. Or maybe you've got another building somewhere else, a remote location where your data is going to be stored. Or you could be storing your data on other clouds, meaning you're on one cloud and you could be putting on another. So during that create phase, we need to know where it's created. And there are threats that are going to be different based upon where the data is created and where the data is transferred from. So if we're dealing with remote data creation, basically it could be you as a user sitting in your home. If you just send that up like FTP like we used to use, that data can be seen along the way. Which is typically why if we were going to upload something, we would typically do it over HTTPS, so to speak, using TLS SSL type encryption. Hopefully. But, think about that ahead of time. So ideally, if you're going to send something, strong encryption should be there. And maybe you encrypt it before you go to the cloud, and then you encrypt it again on the way to the cloud. And honestly, that's what you usually should do. So keep that in the back of your mind. Now, if the data is actually created on the cloud, or being created and then stored on the cloud, the data should be encrypted as soon as it's created. And that way, as soon as it's created, if you don't have the encryption keys, you can't access the decryption keys, you can't access the data. So doing it this way, it's encrypted on the cloud. And at that point, in order to keep keep your encryption working, it's really about how good you are at your key management and what types of key management environments you have. And there's various ways that organizations can choose to do that. And they all have their various strengths and weaknesses. So at some point, now that we've created the data, it has to be stored. And we have to think about this, in our policy that we're going to create and how we want that organization to do it. How and where are they going to store it, and what controls are they going to use? So as soon as the data is created, we have to think about these key security controls. As soon as something's stored, it should have access rights to determine who can access or use that data. That's your typical IAM thing. Now, it could be implemented as an ACL in the operating system. You've got read, write, or full control or something, but somewhere along the line, you've got to limit who can access that data. And ideally, a combination of ACL permissions on the operating itself and strong IAM permissions. So wherever these systems are secured, also, this data they need to be physically secured. So if you're in a cloud provider's data center, hopefully they've got good physical security of their building and good security people in that building. Because if a hacker were to go to that building and plug something into the system, they could have access to the systems based upon, potentially. And that would determine how well the cloud provider was at admission control systems onto their network, and whether they were looking for certain types of MAC addresses, etc. But potentially somebody could just plug into the network and hack through the systems. And when we're storing our data at rest, it should stay encrypted on the cloud, especially potentially in our data center as well, though, because it really doesn't matter. Now, when the data is being used, this is where it can be on the more complex side. So of where the data is and when it's used. And different cloud environments will give you very different interfaces. So different interfaces, different applications, and different APIs when you're using the data on the cloud. And if you're dealing with a hybrid cloud, you may have to translate data through several methods. So you might be transmitting your data from your data center to the cloud provider. You might have an IPsec VPN or a private line running IPsec on top of that private line. And you may still want to use SSL or TLS encryption on the way there. So when we're sending the data, especially across different clouds and different environments, we have to be very secure about how we actually encrypt that data. Now, in order to truly understand how to secure the data when it's being used, We must understand the specific uses of the data and the data flow. So I want to really make that clear. So long before we can think about how we're going to secure the data in use, we need to know how the data is actually moving around the system. That's the most essential part, because if we put it in controls, we can actually break those parts of the system. So we need to know the data flow and how the data is used along the way. Now, maybe a piece of data is transferred 10 different times. An order can be created that can kick off something that says an email to build something. At some point, that could kick off another thing from a customer service department. It could kick off orders from a supply chain to bring in goods to actually make that order. So many things can actually occur. So all this stuff needs to be secured, and that data will need to be secured at every different place that it's deposited along the way, where it's stored there and transmitted along the way. That's the use key. So it's going to hit a lot of different places at the same time. So from an operational perspective, the platforms that are going to connect to the cloud should be secure. So that means if you've got routers and switches connecting to the cloud, which you will, that needs to be secure. But what about the stuff behind those routers and switches at the user's data center that are connecting to the cloud? They may not be secure. So maybe I'll draw this out to kind of put it in perspective. I want to where all the places these can go wrong. So let's say you're here, and these are your campuses, and this is your campus and your users. And this is why networks have to be segmented. Let me see if I can fix this. Change the font color so it can be seen. So here's our campus and users. And architecturally, here's our cloud provider. And it really doesn't matter where it's at. If we've got a user here and we've got we can have a secure connection to the cloud provider. And actually, here's the way a private connection would typically look to a cloud provider. The organization would typically they'd have a router, they would buy a wide area connection to a direct connection location, which is basically a point of presence. This is going to be called a provider edge router. This is going to be the customer's router. And actually I'll make it a direct connect location or direct interconnect location, point of presence, whatever you want to call it for any cloud provider. So we'll buy a link from the router on our campus to the provider edge, actually it's our customer edge router. This is our router we're buying a wide area connection to in one of these direct connection facilities or point of presence facilities. The provider themselves will actually have their switch here, and then there will be a layer 2 backhaul of very high speed gigabit Ethernet. And when I say gigabit Ethernet, we're talking multiple 100 gigabit Ethernet pipes, many of them. And they'll just use a VLAN or a .1Q trunk along the way to keep people's traffic separated. So this is kind of the way this happens. So this is a secure connection, realistically speaking. Now this could be further enhanced with an IPsec tunnel to further encrypt the data that's going across this connection. And all of that's great. But if you have an infected user over here, and call this the infected user, and you don't block it, and along the way, that infected user can infect your systems in the cloud. And likewise, it could happen on either way. So when we're talking about the need to secure each and every one of these environments, it's because at any hop along the way, if we have a weakness in the system, that becomes the point of attack. Kind of hope that made sense. So while we're talking about the data and it's being used, think about what happens when employees bring in their own devices that you don't own. It makes them harder to control. So we may actually have to force a minimum patch level on a certain system where the user can't attach to the network. So there's things that can be done architecturally to deal with this, but understand every single device and hop along the way where the data is going to be used, that needs to be secure. So we can't secure it all with technology. Some of it's about the user behavior. For example, if a person logs into their computer and then walks away for 5 minutes, chances are people can access information that's on that person's computer if they don't lock their system. So a lot of user education has to go with regards to how the data is being used as well. Now, when the data is being used, we should also look into rights and role management. So the data owners themselves, and we talked about who they were yesterday, they should classify, protect, and oversee their data usage. Because if you own the data and you're responsible for the data, you're responsible for what happens to it along the way. Which means when the data is used, we should be using permissions or access rights that are as little as possible to get the job done. Kind of like in the top secret environment or the need to know environment. If you don't need to know, you don't need to know. Well, in this case, it's typically called the principle of least privilege, which is don't give people access to anything more than they need to know to do their job. And the same thing applies to data. Don't give people access to more data than they need to know to do their job. And anytime people are going to access sensitive data, we want to log that data and create an audit trail to see where the data went, just in case the data was manipulated or changed along the way. We need to know when it happened, where it happened, and by whom. So we talked about the data in use. Let's talk about sharing data. So when we collaborate globally, we create an incredible opportunity to work with others across all parts of the world, which is a wonderful thing. But when we collaborate globally, we also open ourselves to different risks in different environments and different places that have different laws and different things that are outside of our control. So all this will determine the way the security policy needs to be and the security systems that we need. So we've got that global collaboration risk, which is normal for the way we normally do business now. So that means there can be threats coming from any part of the planet. And that means if we have any weaknesses in our system and they break in one part of the planet, well, then they can get into the rest of our system. So all systems are going to need some degree of control to the same level. We can't have a weakness in the system because that could be where we're attacked from. So when the data is shared, let's talk about security controls. So we still want to use things like encrypted files and encrypted communications. So encrypt it when you store it and encrypt it before you share it, meaning encrypt it over the wire, things like IPsec, SSL, TLS type encryption. Make sure we're using rights management to make sure that the people that shouldn't have access to the data can't get access to the data. And anytime we're going to be creating data or sharing data or moving data, we talked about the need to tag the data and add permissions to the data to control who can access it, who can modify it, who can destroy it, what have you. So when data is being shared, we have to think about the legal environments and requirements which are going on. Because as we're in different jurisdictions, there's different laws. There's different rules in UAE than there are in Canada, than there are in Greece. And as we're sharing data, we're now in different parts of the world, which all have different laws. So we have to be considerate of that the entire way. So sometimes we have to create sharing restrictions based upon jurisdictional or legal requirements. So if I'm a company and I'm making in America some form of super high-grade encryption, I may not be able to export that type of encryption overseas for legal requirements. So I'd make sure my data, if I had some special encryption mechanism, couldn't be shared to other parts of the world to comply with legal requirements. So think about how challenging that is sometimes to get done on the cloud where the provider moves things. So that's where you need real control of data sovereignty. You need to know where that cloud provider is moving things. So I kind of hope that makes sense. So when we deal with any kind of changing where the data is moving and we deal with different jurisdictions and legal requirements, they have to have limitations in place. So we can make sure our data doesn't go to the parts of the world where it's not supposed to. Which means when we're sharing data, for the most part, at least someone in our company needs to be responsible for understanding import and export controls in all the regions where our data must be shared. Sounds like a great job for a lawyer, doesn't it? And that's why companies have lawyers that evaluate these types of things in their governance compliance type teams. So at some point, we're going to archive the data. And at this point, we want to make sure that the data is being stored. and it's going to be stored in an intelligent manner. And we need to have, at this point, extended security on our data for a long period of time. And that means we need to make sure the data doesn't leave the system. So typically in an environment like this, we can do something called egress monitoring. And egress is when things leave your system, and ingress is when things come into your system. So we can do something called egress monitoring, where we track what's actually being sent. And if some of that private data seems to be like it's being sent, you can stop that data from being sent in the future, and you can go back and see who's sharing the data. So, egress data monitoring may prevent you from sending data that you don't want to send. When the data is being archived, now it needs to be stored for longer, right? And it's not going to be monitored quite as much. So we typically need better encryption. So at this point, we need to have a very strong encryption algorithm we're using. We should be using a strong encryption algorithm the whole time, but if we weren't, now would be the time to encrypt it a little more. If we're going to be doing long-term archival and we're going to be using encryption, well, now we need to make sure that we manage our decryption keys and our key management, because mismanaged keys will either mean the data exposed, which you don't want it to happen, or the data could be lost. So keep that. Now, here's what you don't want to do. Don't store your encryption keys and your decryption keys in the same place as your data. So that's kind of like having a file on your phone that's got a list of all your passwords that you can see, and then leaving your phone out in the middle of the room open. They'd basically see your phone, have access to all your passwords, and even know what the device would be in. But you'd be surprised. People sometimes literally store their most critical secrets in the same place as that data, and that's an absolute disaster. And when we talk about secure coding practices, we have to talk about making sure people don't just put API strings and other keys inside of their code, but we'll get to that in another part in this program. So more about what we're doing in the archive phase, a little bit about a physical security. If we're going to store our data for a long period of time, where are we going to put it? Where are we going to store it? So are we storing it in a facility we have? If we have that facility, what's the level of security in that facility? What environmental risks exist for that facility? So natural disasters, hurricanes, war. So if we've got this facility where the jurisdictional considerations, either local or national laws we have about that facility. Now, if we store our data in a specific facility, what happens if that area is in an emergency? Can we get into that? What are the contingencies we have around that facility itself? And is it far from the production environment where that business does its main operations, this facility? Is it far away? If it's far away, we get the protection of what happens if it's a regional disaster. If it's far away, it's going to be pretty hard to get to in certain cases if we need access to physical devices, if it's not virtual devices. So it's kind of here. And, when it deals with it, we're dealing with archiving. Are we going to be copying our data to multiple places? So did we send our data somewhere else? Is that system backed up via a tape system, which is sent somewhere else? We have to think about all of this, because each one of these locations is a risk. So archiving. If we store the data on physical media, tape, ship a bunch of hard drives each time, can that data be replicated? Can those tapes be damaged or destroyed? Yes. What happens if someone steals the tapes? What kind of encryption is going to take to break the tape? So this kind of stuff needs to be planned in the archive phase. If the media is portable, that you're using for archival purposes, meaning easy to take from point A to point B, now you need extra security against theft, because it can be stolen. It can be stolen easily. For example, it's much easier to steal something that's the size of an iPhone than it would be to steal something that's the size of a hotel. So kind of think about all these when you're dealing with your storage and you're planning on, when you archive it, what kind of security type systems you need. How long do we need to keep the data? And if we store it in a certain format, will that format even be available in future hardware? For example, I actually have some training tapes from executive coaches 15 years ago that were on VHS tape, and I don't even know if I could watch them anymore without finding some way to transfer them into an audio-visual file on my computer. But it's that same kind of thing. Are we storing it in the media that's there? It'd be pretty hard to go back to old school 5 1/4 floppy disks to actually get something there. Now, we couldn't store a lot of data on them anyway, but I hope that you see what I mean by the point. Now, if we're going to store our data in a building, what kind of staff do we need for security? Can we hire foreign nationals, or are we legally obligated to keep only domestic citizens there? What kind of people do we need doing the security? Do we need standard security guards? Do we need security guards plus guards? Do we need security guards plus snipers on the roof? I mean, it depends on what the kind of data you're storing, what the levels that organizations will go. But think about that when the data is being archived. And what are the procedures? So, if data is archived, what's it going to take to bring it back to recover it when it's needed? If it's on the cloud, it's pretty easy. But 98% of organizations are multi-cloud and hybrid multi-cloud, so data could be anywhere. Data centers, co-location centers, disaster recovery, shared environments, other cloud providers. So we really need to determine how the data is going to be moved and how it's going to be archived. And when it comes to backups, are they going to do full backups, incremental backups, and differential backups? And we will talk about that at some point throughout this program. And then we back up our data or archive it, because we've got to back up our archives. Where do we do it? Do we put our data on the cloud? Now, do we put it on the same cloud provider we have, but in a different region? Do we pop it to one cloud and back it up to another cloud? And each one of these opportunities has different strengths and weaknesses. Taking it from the data center, moving it to one cloud, and then backing up to another cloud, well, that gives you, for the most part, the greatest availability and the greatest likelihood your data is going to be there. But it's a more complicated security architecture along the way. What are the availability needs of the business? That'll determine if it makes sense. I kind of hope these things are kind of making sense. So lots of questions to ask here. Now, when it's time to destroy our data, we're gonna on the cloud. We talked a little bit yesterday. We've got to do some kind of crypto shredding of our data. In our data center, we can literally destroy the drives. We can do anything we want. We could take our drives in the data center. We could degauss them. We could drill holes through them. We can burn them in a fire. And the cloud providers don't do that every time we destroy data. So we have to use this kind of cryptographic eraser or crypto shredding. And basically what it means is you encrypt your data. I know we discussed it a little bit yesterday with a very high degree of encryption. And then you basically destroy the decryption key. So at that point, nobody can ever recover the data. And if you don't destroy that encryption key, then the data could be decrypted later, and then the data is just there, and nothing has actually been changed. So a little more about the destroy phase, and then we'll get to some questions. So when we're dealing with cloud providers, they may handle the entire data lifecycle, especially in a software as a service environment and a platform as a service environment. So that means you have basically no control over it. So you may have to think about putting some data lifecycle requirements in the contracts you make with the providers themselves. And you're going to have to plan for a data recovery if you're switching vendors. Like if a new vendor is acquired or someone goes out of business, you should always plan this in mind. What happens if a cloud provider kicks a business out of their cloud? It's happened. For whatever reasons, the cloud provider doesn't agree with an organization's type of business or whatever. They say they violate their terms, they kick them out. And maybe they did violate their terms. That business needs to be able to plan to what it can do next. So it's always about planning for the unknown variables, planning for the unknown and unknowable variables to the best you possibly can. So let's break here, and then we'll start talking about storage after we answer some questions.
All right, let's take a look at what our first question is. It is from Chris Blackwell. He's wondering, is there really a difference between zero trust and least privilege access? Let me explain it this way to you, Chris. Zero trust is a framework when it comes to security architecture, just as much as the NIST cybersecurity framework would be just a framework. Those are called guidelines, ways that we can architect or design a system that would give us the least amount of threat surfaces, that would give us a possibility to do proper heat mapping in case we need to figure out like a gap analysis. And at the same time, if we need to do some kind of threat modeling, these provide us guidelines that we can implement into our current architecture. The least privilege access is actually one of the core tenets or cornerstones, you might call them, when it comes to what makes up the zero trust architecture. So in essence, they are separate entities, but come together to make up a overall security strategy that somebody can have. And that's in simple terms. There's a lot more to it, of course, different components that come with it. What in a brownfield employment you would use, which is basically an existing infrastructure or security posture that you have, on how you would actually use that. But they are, when you look at a framework, they're part of each other. And this is from Willie. He's wondering, is egress monitoring done through data loss prevention tools, or is it something separate? Willie, that would depend on your data loss prevention tool. Most of the time, though, data loss prevention will also be used for monitoring because it will have access to the data that it can also analyze. So depending on, though, if you use an open source, or as Mike mentioned yesterday, there's also commercial systems that you can put in place. It's going to vary a little bit in regards to its functionality. I like to look at tools very similar, like I do with security information event management systems, where you will have an umbrella term that encompasses a particular software or system or platform, and then you may have to have add-ons to it. Now, if these add-ons are there from the get-go or not, that depends again on the software. But for all intents and purposes, yes, egress monitoring is included in data loss prevention tools. Let's take a look at what our next question is. Good questions.
Very.
From Scooby, future hardware exactly. Could there please be more focus on GPU optimization for future proofs, such as 65 GPUs that are used for chem generation? Well, Scooby, what we're trying to discuss here is part of the CCSP material. So GPU hardware and future optimization based on particular scenarios is not necessarily coverage part of when it comes to CCSP. That might be involved in some future training when we're focusing on that. So that's also a little bit more architecture, especially if you're talking about more cloud architecture compared to just security architecture.
Yes.
And from Kennedy Wadia, he's wondering, for those of us in developing countries where cloud computing infrastructure is still developing, what are the major challenges that we must overcome? What major problems has cloud computing solved? And a third question from him is, what are the potential threats to cloud computing in our developing countries?
So
you okay if I start this one off, Mike?
Sure.
Okay, I'll take one. I'm going to take the most obvious one here, Kennedy, for you, and that's going to have to do with infrastructure limitations. So if we're talking about in developing countries, there's going to be a limitations in regards to bandwidth and connectivity that we're going to be able to have. And that's also then going to couple in, do we have data center availability? So from that perspective, the infrastructure is going to be one of those limitations that we're going to deal with. And then an extension, of course, also the cost. because believe it or not, money does make the world go around. And if we don't have investments into these type of solutions, then it's going to be very difficult to even build out that infrastructure. So it's kind of like a chain that we see happening there. What are your thoughts on that, Mike?
And I really want to make it clear, Kennedy. Cloud computing is nothing more than a network in a data center. So it's nothing different than we've been doing tech-wise for the last 30 or more years. The only difference is instead of us building it ourselves, somebody else builds it for us, and they charge us to rent space in it. So realistically speaking, it's not that cloud computing is solving any problems, but it can still help us in certain ways. In certain cases, the cloud providers will give a small amount of money in the form of credits to new businesses. And that business can start. They can use those thousands of dollars of free credits. And by the time that business is starting to make some money, they have technology behind them. So sometimes it gives businesses the ability to start building out their technology systems for free. And my family's from a developing nation as well, and I can tell you quite now, when you don't have the financial challenge of what money do I have to come up with to start a business, that can be incredibly helpful. The second side of it is, it will be in most cases more expensive to rent the infrastructure. But if there's no infrastructure there and it's hard to get a lot of the infrastructure there, like it would be in my village in Greece, for example, although it's gotten better in recent years, in an environment like this, having access to something that's made, that's good and strong and modern, as opposed to trying to figure out the challenges of trying to build it yourself, well, that in and of itself is a big, huge advantage. So having access to modern technology, that's really the thing and the key to keep remembering. And I agree with Mark completely. Can the people in the regions afford it? And that's another story that's there. And I can also tell you the concept of the infrastructure. For example, one of the people that works for us that lives in Cameroon, it was about 14 router hops before he was able to get to the internet, where it might normally be in certain places 1 or 2 hops. So we need to have good, strong networking and all that power and all that type of network infrastructure to get to the cloud for the people who are able to use it maximally. But it's growing everywhere. We're seeing some places, Lagos, Nigeria, Cape Town, South Africa, they're investing heavily. And we're seeing it in other countries as well. And I think it's exciting times. So they're really, regarding the threats, and I guess I'll finish on this. The threats are that it's too expensive for people to actually purchase it. And I say this because in some cases it would be cheaper, far cheaper to buy refurbished server hardware and build your own data center and refurbished network hardware. But at the same time, does it really matter? So in some cases, let's say people are buying some refurbished servers that are still quite strong and powerful and refurbished routers and switches, and they're building a small community cloud right now. And if a bunch of them were to develop and to provide a good computing access to a country, that's wonderful. Or it could be a big major cloud provider and they could win because they can come in, they've got the economy of scale, they've got the business, they've got the funding and financing to do it, bringing in their technology. But in either case, it's a win. So I don't really see the threats to cloud computing in developing nations, unless other people bring in a different type of technology infrastructure that would give you the same type of performance, like private clouds or private data centers. And again, that's actually cloud computing too. It's called a private cloud.
From Tony, is there an intersection between cybersecurity and AI for someone interested in both fields? What would the job role entail or be called? For example, AI security architect.
So let's talk about it from a career perspective. AI is all about innovation and enhancing productivity. Security is about protecting an organization and minimizing the impact on productivity. So they're kind of exact opposite careers. In one case, they're hiring you to protect someone. And in another case, they're asking you to basically create a profitable business investment for them. So for the most part, if you try to combine them, you're going to be equally bad at both because you're going to have conflating efforts, and it's going to probably hurt you salary-wise. So if you like both, I probably wouldn't do it. Now, where would there be opportunity in AI? working for companies like Palo Alto or Fortinet or Checkpoint and Cisco, because they're going to have good AI people that are working with their security devices right now to try to make it better. But they need many more of the techie AI-oriented engineers as opposed to the architect side, because they need, a few hundred of them one time to try to make that product, and the rest of it's going to be done by the same security architects and engineers. So it's a very finite skill to try to combine them. But at least at this point.
From Scooby, is this crypto shredding optimal for one-time password key scenario? Scooby, it depends.
Yeah.
And the reason I say it depends is you're talking about a combination of systems working together. So it would immediately depend on how is your key management system implemented, and what is your strategy in regards to that, and then what does the security around that system look like? And then the one other thing that you really need to keep in mind is always going to be, what are your compliance obligations too? Because if you have very strict compliance in where you are or governance, then using something like a one-time password is not going to be I don't want to say a valid solution, but it's not going to be the best solution that you can pick for that. But outside of that, again, it's going to have to come down to a business driver, a business case. And when it comes to security, always compliance and governments to make sure. And then eventually you will have risk management also in case, because you eventually will have to figure out, is it going to be a benefit that those keys are ephemeral to you, meaning they only exist in that moment in time and then they're gone? Or do you need some type of ability to audit them later? It really depends on the use case that you're going to have. So it's not a simple yes or no answer.
Yeah. And there's never an optimal anything. Ever. Everything is a new situation. We have to weigh all the facts, all the goals, all the challenges, and then after examining all the evidence, then we can pick the best one. I wish this was so easy that this is always the best option, but it's not.
From Daryl Johnson, they're wondering, how can I get my first job in this industry?
So join us tomorrow on the How to Get Your First Cloud Job webinar. We're going to cover the architect role. But whether it's an architect role or an engineering role, they both require a completely different set of skills. But there's a certain set of things that you need to do, and a certain set of things that you really need to have. And we'll discuss that on tomorrow's completely free How to Get Your First Cloud Job webinar. It'll be on Zoom too. And because it's on Zoom, you'll be able to ask questions, and we can ask you questions and have a meaningful dialogue to truly help you. We're going to do a couple more, and then we'll get back to the content.
Okay. Question from Paul. They're wondering, are escrow keys, so basically keys that are going to be held by a third party, needed for cloud environments too, specifically for legal requirements? Here we're going back to the answer we just gave. It's going to depend. And what I mean with that is, what are my legal and compliance requirements? If I'm working, let's say, in healthcare, my requirements there are going to be different than if I'm providing simply software as a service, just as an example, if I'm selling a software. So in that essence, if you want to think of it, the more sensitive something is going to be, the more likely it is that you will be required to have somebody hold those keys for you. But then also then we're going to go down the rabbit hole in regards to, if we want to think third party as a cloud vendor, how are they storing those keys? How eventually are they going to get rid of those keys? So again, it's not a simple yes or no answer, but definitely there is going to be legal requirements that will have to be met for you to even consider using escrow keys or placing your keys with a third party. Okay, question from Nigel. They're wondering, how do you audit cloud service providers to ensure they're securing your data in line with a contract or as they promised to?
So this is the thing. You can't. So there are going to be third-party auditors that are going to be paid by the company to audit their books and review their systems. So let me put it clearly to you. I'm a company. I pay somebody $50 to $100 million a year to audit my security measures to publish a report that says my security measures are in line. And hopefully the people are honest and ethical enough doing that audit report to do it. But you can't walk into them and you can't audit them. So it's a lot of it is faith. It's faith in the actual auditors that are paid by the companies to give you an honest and definitive answer. So keep that in the back of your mind. I'm only saying this because, I look at the systems holistically, and you got a couple little places over there where there's motivations for the report to be good. If you do the audit and you give a bad report, you get invited to do that $100 million audit in the future. At the same time, we have to assume most auditors are good, honest, and ethical in what they do. But there's no way that we can walk in there and we can actually truly do it.
All right, and let's take a look at one more question here before we move back onto the content itself. And this is going to be from Willie Sanchez. He's wondering, is crypto shredding the only way to destroy data on the cloud? How to be sure cloud providers has done it completely and correctly? Now, this is a yes or no answer, and it is no. It is not the only way to do it. Yeah. You can do something which has been traditionally used back in the day with when you think of mechanical spinning hard drives. You can just keep overriding the data multiple times, and that eventually is going to actually phase out the data. You, of course, has always the option of using some type of physical stress or physical destruction to do so. So those are always going to be your alternatives to it. Now, can you make sure that a cloud provider has done it completely and correctly? Well, unless you're going to be standing next to them while you're doing that, you will have to take their word for it. And their word, I specifically mean the contract that you signed with them. Because within that contract, they will have to state how the actual destruction of data does come about and what your options are. And yesterday, and I don't know if you recall this, Willie, we mentioned that depending on the amount of money that you do spend with a vendor, there could be sometimes these perks where you might know a little bit more than what they publicly will share, let's say through the documentation or so forth. So those are always going to be some options. But by default, unless you're standing right next to them, there's no way of really knowing it. You kind of have to take their word for it and hope that they execute on it. Okay, I believe that is all for right now, Mike. Now, before we move on, let's go back to the spirit how we started this session. If everybody could put a hashtag CCSP into the chat box, please. That way we can get a heartbeat, make sure it's still ticking for everybody. You're still engaged.
And actually, if you're enjoying the content, if you can give it a like, if you're not a subscriber, subscribe, hit the bell to be notified of new videos. See, I'm learning about YouTube. I actually love being able to communicate with people all over the world, but I'm not the person that's known for social media. But love going.
What is it? Subscribe, like, hit the notification bell. We're trying to get down with the YouTube lingo. But for everybody, you're very welcome. We sincerely are happy to be able to be here to share knowledge and also the experience that comes with it. And we're hoping that as we go through the few more hours here and in the days, that this will be of real value to everybody. And more importantly, that you have fun learning these concepts and look for opportunities to be able to apply them. So in either case, Mike, absolutely. I'm going to turn it over to you again.
Sounds great. And make sure if you don't have the ebook that goes with this course, you download it. Chris from my team will pop it there, and hope to see so many of you in the free Zoom webinar where we talk about how to enter an architect career. All right, let's talk a little bit about storage. I love storage. So we have our data and we need to store it somewhere. And we've got the opportunity to store it in places for long-term periods of time on the cloud. So lots of types of storage. So storage option one that we're going to talk about, long-term storage, is going to be block storage. And block storage is basically it's going to be object storage. And typically in these environments, they're going to have their own long-term storage tier. So AWS's is called Glacier. Google's got their long-term storage tier called Cold Line and archive tiers. Azure has their archive storage, and that's basically long-term object storage. And that's typically used when you use this long-term storage because you're using it either for a backup, which you want to keep for a long period of time, or regulatory compliance. You're in an industry where you're highly regulated and you need to keep a lot of data for a long period of time, like healthcare. You're keeping patient records for 7 years. Or banking, you're keeping transaction logs of stock trades, that kind of things for SEC purposes. So, those types of reasons. So the cloud vendors are going to offer multiple tiers of storage for both frequent or as well as long-term. In the cloud, we're also going to have what's called ephemeral storage. So when we launch an instance, or basically a virtual machine in a cloud, it's going to have its own hard drive. Now, the hard drive that our virtual machines take are typically in that actual server itself. And being in that server, they're going to be really fast. Here's the problem with the storage inside of the server in most cloud providers, and actually all cloud providers, is it's ephemeral, meaning I create a virtual machine, Cindy the Cat's virtual machine. I delete Cindy the Cat's virtual machine, and all of Cindy the Cat's server data is completely lost. So kind of keep that in the back of your mind. So we need some other form of storage to actually store our data. When we're going to be connecting from a virtual machine to virtual storage in the cloud, it'll be block storage. When we archive our data, it's going to be object storage. If you need me to talk more about either one of those two, comment the type of storage in the chat box, and I'll do so while we're going through storage. But understand that typical storage that exists, that ephemeral storage, is not going to be good enough. So when we're dealing with the virtual machine, we're going to have some kind of logical volume, like a data drive that we store for. And if we were dealing with the Windows virtual machine and we mounted an additional storage volume, it would be assigned a letter. In Linux and Unix, we're going to mount a volume, and it'll be started as whatever we mount it as. But the storage volume that we're actually talking about is going to be storage that's going to be over the network. It's going to be a block storage environment. So in an infrastructure as a service environment, a virtual machine environment as a cloud, we're going to attach a storage volume to block storage. And next, we're going to talk about file-based storage. So, and maybe I'll just draw these out for you in a minute if that would be helpful to you. So in file-based storage, it's either the hard drive that's sitting inside the server, or I have a server, I'm going to share something on that server, and it's going to be accessed by a whole lot of systems. So maybe it's time for me to kind of take some of this down and actually teach it to you the way that I would teach it myself. So let me gonna map some of these things out for you. I'm going to get a little. I gave you what you needed for the exam part about the storage, so let's break it down into architectural purposes a little differently. So in this particular environment, we're going to look at our three storage types. So let's say the data here is a photo. Now this photo can be stored in block storage, object storage, or file storage. So let's look at what the cloud provider storage arrays really are. They're basically going to have a device, and it's going to be this big giant box, and it's going to have a CPU to do processing tasks, and some DRAM. And what it's going to have is it's going to have a bunch of hard drives in here. Hold on. And they'll be up in lines, but for argument's sake, this is going to be quick. This device is going to be filled with hard drives. That didn't work, right? Okay, so these are typically your storage arrays. These are big servers with a whole bunch of hard drive slots. Each one of these things represents a hard drive, and the data, what's going to happen is it's going to be sending this data across all these drives while adding backup data. So if anything were to happen, we can remove a bad drive, pop in a new drive, reconstituted data. So these devices use some flavor of RAID. And if this is the way all storage area networks. So whether it's block storage, object storage, file storage, you're always going to have these environments. Now, what'll happen is these environments in today's world, they have Ethernet cards in them. They used to have something called a fiber channel card in them. It was a separate network and switch that we actually did. And actually, just to make this kind of content, we'll put a switch here. Let me get rid of the photo here. This is just so you understand that all three types of networking of storage systems we're going to talk about right now are actually network storage. So here we've got a switch, and all these network connections connect back to the switch. And the reason this works is all of these storage systems are in the switch. Now you've got a server sitting in the cloud provider. The server is plugged into the switch. So because the server has access to this switch/router, depending upon layer 3, layer 2. But anyway, the point is the switch can access the hard drives. That's why this is network attached storage. These are storage area networks, whatever you want to call them, because they're accessed over a network. Now, where they're different is this. If we now have a virtual machine, now that I don't care whether you call this an EC2 instance on AWS, or Google calls it a compute engine instance, or Azure calls it a virtual machine. That's that virtual machine we talked about on the first day where I explained the hypervisor to you and showed you our VMware ESXi environment. On what the storage that comes inside of this virtual machine, this is ephemeral storage. So that means if you delete this virtual machine, the storage is gone. So in the cloud computing environment, we can't actually do that. Now, we can have the storage area network over here that's the block storage environment. And what it can offer us is we can get a virtual hard drive. It's a virtual drive. Make this a little bigger. And the virtual hard drive is really sitting on this block storage environment. But what happens is normally when you take a data, let's say it's a photo of Cindy the cat. When you write that data to your local hard drive in your computer, you typically store it in blocks. Now, what's going on here, this block storage environment, we actually have this virtual hard drive we create there, and then this virtual machine attaches that virtual hard drive as if it was actually located inside of it, even though it's being accessed over the server. Let me just lower this a little bit so you can see it all. And by doing so, this is how each virtual machine accesses block storage. It's like a virtual hard drive. So in the cloud environment and the data center environment, if we don't want data local to our systems, we use block storage. Here's where we use file storage. Either this local hard drive that's booting the operating system and the server is file storage. Here's the other use case where we would use file storage. For example, let's say we have a file server. If it's Linux, we would basically create a share on the server that would be called an NFS share. We use that network file system. And now we could have a bunch of computers. I'll give you an example. Let's say server. Let's make a couple of them. If I had all these servers, the one that accessed the same information, this server would share it, and any one of these servers could access the information that was shared. Now, that's typically why we're using file storage, because we want others to be able to access and see what's on these systems. They can all share the information at the same time. Here's the other thing that you should think of with file storage. basically you're going to have a main folder. So this could be your folder. That could be your C drive. And inside of your folder, you're going to have a subfolder. So you might have this as a folder inside of your folder. So this could be your documents folder. This could be your, let's see, presentations. Got to change the font here. And inside of your presentations folder, you could have another folder that could be presentations for a security conference. So file storage is hierarchical in that not only can we have one device shared amongst many, but we can store it in a hierarchical manner. So we talked about block storage, which is a virtual hard drive, effectively in a virtual machine. We talked all about these types of storage environments being attached to the network. So now let's talk a little bit about object storage. So let's say we have some data over here, and this data is a cat photo. So it's cat.jpg. So that's the name of it. And sorry, I really like cats. I like dogs. I like birds. I just like animals. Actually, love animals. But so let's say we've got that the cat is what we're storing. Now in this object storage environment, something very interesting happens because this is not normal storage. The cat.jpg actually gets, when it's stored, it's referred to technically as an object, and it's stored in the form of an object. It's no longer a JPEG. It's technically an object now. Now, the funny thing about this object is we can actually have metadata. So now it's got this metadata thing. So now if we really want to be careful, we can say Cindy, because she's my cat Cindy, and I got way too many cat photos. Cindy eating shrimp, because my cat really loves shrimp. So I could actually tag that with the metadata. The other thing that's pretty interesting is there's no hierarchy in the storage. What happens is when the information is stored, what gets created is there's this little memory pointer, and it will basically tell the storage area network where in this entire environment the cat JPEG is versus every other thing which is going to be sitting in here. So it's really, really odd. So this could be dog.jpg, whatever it wants to be. It doesn't matter. All this stuff from all these environments are all going to be sitting in the same place. No hierarchy whatsoever, but you'll be able to retrieve your items because there's a memory pointer to the exact location of where things are. Now, this type of storage, this object storage that we're talking about, we can't mount it to a hard drive. So it's really good for backup and archival purposes, software distribution, playing your Netflix video, that kind of thing. That's where we'd use object storage. So block storage, virtual hard drive in a virtual machine. Object storage, long-term, backup, archival purposes, that sort of thing. File storage, either what's in your PC, or it's when you want multiple servers or people to be access the same data at the same time. And there you go. So a little more about these storage types now that we've talked about them. When we're dealing with block storage, it's actually slow compared to traditional data center storage, but it's the fastest thing we get for the cloud. So when we deal with cloud providers, they will give us the opportunity to leverage various forms of block storage. And they will all have differing performance speeds. For example, in AWS, we've got where their version of block storage is elastic block storage. Azure uses managed disks. It doesn't matter. All the cloud providers use block storage. But with AWS, you've got your provisioned IOPS1 and your provisioned IOPS2, which are the fastest they offer, and their performance in terms of IOPS, or input and output operations per second, and throughput. So they vary a lot. So if you're curious and you're learning storage and you hear the term IOPS, that's input and output operations per second. That's how many times the drive can read and write per second. the latency of so your latency is going to be inversely correlated to how long it takes to read and write to this drive. Throughput, when you hear drives, is going to be measured in, say, megabit or gigabit per second, and that's going to be about how much stuff you can move. So I always envision in my head having two vehicles. The low latency vehicle, which is that high IOPS, is like a Ferrari. You get in that car, you hit the gas, and poof, it goes. By comparison, it's a pretty small car. How much stuff could I carry in that fast Ferrari? Whatever I can put in the trunk. Not a whole heck of a lot. Now, my second car would be a tractor trailer. This thing, you can put 40, 50,000 pounds of stuff in. But now you try to race that Ferrari, it's not going to work. So the throughput is the amount of stuff that can be moved. And the latency is measured in the IOPS is an inverse correlation of latency, how many times you can read and write per second. The higher the number, the lower the latency. I kind of hope that makes sense when we're talking block storage, because if you're dealing with the database, it's going to need more input and output operations per second potentially than just something that's, how do you download Linux? Kind of hope the Linux download website. Hope that makes sense. So a little more on object storage. When I talked about object-based storage, I talked about the metadata, or the data about the data. Now, there's always going to be a unique identifier. And that's really going to be what's used to locate the specific object, which is what I referred to that memory pointer. How do you find that object? But because we've got metadata here, we can do our data marking, our data labeling, our data classification, our data categorization. So yesterday, when we talked about categorizing data and making it that you know who the data creator is and version control and all these wonderful things, that lends itself so elegantly to object-based storage, because object-based storage is much like a database. You throw everything there and it knows how to find you through that pointer to get to the location. So kind of hope that makes sense. Now, because we're dealing with object storage and we've got all this metadata that we've just talked about, finding information is pretty easy. I can search which has a video of my cat Cindy chasing squirrels, and chances are it'll find me the 10 squirrel-based cat chasing the videos at once, if that's what I was looking for, and that's powerful. Now, because we've got all this metadata, we've got a lot of information with object storage, we have the ability to basically enable digital policy enforcement. So, object storage typically supports information rights management and data loss prevention strategies. And typically, these environments are centralized management, and they give you centralized control of your data and your data functions. So that's typically why lots of organizations use object storage for big data. The ability to store it there and the ability to tag it, label it, categorize it is one of the reasons that we use so much object storage in cloud computing. And if we were going to create a data lake, for example, that's where we're going to take the information out of, say, our relational databases and our NoSQL databases and our data warehouses and object storage, and we'd map and reduce that data, normalize that data, clean that data. We'd store it in object storage for future use for those reasons. Okay, now let's talk briefly about databases. So organizations use databases for pretty much everything. The key here is a database typically provides a good structure to be able to store data, but also retrieve it easily. And typically databases have a primary key, which is where most things are. You can use typically a secondary key or create a secondary partition or various things if you want to partition databases, but that's way beyond this. That's more in the database architect world, as well as the database administrator world, not anything we're talking about from a security perspective. Now, if we deal with databases on the cloud, they typically access backend storage through an online API going back to, say, what are you talking about? I'm sorry, block storage, which is typically in the cloud, in the cloud provider. Now, when we use databases in the cloud, what kind of databases can we use? The same ones we've been using data in data centers for the last 30 years, because the cloud is just somebody else's data center. So we have relational databases, typical databases like Oracle, MySQL, Microsoft SQL, MariaDB. They're typically used in high transaction workloads, those types of things, databases, backend storage for a whole lot of things. No SQL databases, or not only structured query language databases, are more of your key value and document-oriented databases. You'll see them everywhere. Flexibility. So if you want to figure out where you're at in a Netflix movie, they're going to store that in a, in a NoSQL database. I'm pretty sure they use Apache Cassandra. But that's typically what you're actually dealing with. And the last kind of database we're going to deal with are data warehouses like Postgres. Now, the cloud providers also have their own data warehouses. For example, AWS has Redshift. But in a multi-cloud environment, we probably need to stick with more industry standards like Postgres, because we can run them across multiple clouds. Not that we necessarily would do data warehouses across multiple clouds. Now, when we're using databases in the cloud, we have lots of options. So option one is we can bring our own database in a virtual machine exactly as we have done for the last 30 years, and it works great. Option two is we have a platform as a service type database and a software as a service type database with the cloud providers. So we'll talk about that. When it comes to security considerations of your databases in the cloud, here's one of the things you can do to maximize your security. Minimize what you store. Minimize your data sets. So what else can we do to make it better? So whenever possible, we can use things like anonymization or pseudonymization, basically protect our data and make our data less valuable to others. So we could also do things like that. So let's talk about the designing and applying security strategies for storage. And there's lots of technologies that are going to be covered here in the CSP exam. Things like encryption and key management and hashing and data obfuscation and tokenization, data loss prevention and key and secrets and certificate management. So let's talk briefly about encryption. Encryption is basically taking what you have and turning into gibberish if you don't have access to the decryption key. So it's typically performed via math. Now, there's strong forms of encryption and weak forms of encryption. A weak form of encryption would be Yasas, posisa olisimera, ogoim o Mike. Now, going out there and saying, "Hi, everyone, my name is Mike," in Greek isn't that great of an encryption, because, there's about 10 million people in Greece that speak Greek, about 5 million people in Australia, Melbourne, or specifically that speak Greek, and some people in the US like me that speak Greek. So it's not going to be the most significant form of encryption, but it's still some. And as we get into math, we can get into much more complicated mathematical calculations that we use to encrypt things. So we use encryption for lots of things to protect data at rest, in transit, and in use. We'll also talk about encryption through this presentation, about using it to make sure our endpoints are who they claim to be, and so many things more. But with regards to data, we want to use encryption to protect our data at rest, in transit, and at use. So in usage, meaning in transit. Anytime we're going to move our data from one place to another, it is in transit. So ideally, we can encrypt that along the way. Now, what does that mean? Well, if it's a private line, theoretically it's private, and we shouldn't need to encrypt it, but we might encrypt it to make sure that anybody that would access anything on the wire couldn't see it, so we might encrypt it anyway. So how do we encrypt stuff in transit? Well, we can encrypt the entire wire with the IPsec protocol. We can also encrypt it, from the sender to the location with SSL TLS via things like secure copy or SFTP, or through a browser, that kind of thing. So inside of an enterprise, we can actually provide data encryption the entire way if we want over the IP network, if we chose to. And if we're inside of our data center, we want to, it's a little less challenging than if we're in a cloud provider's data center who may have thousands and thousands and thousands of customers in the same building on the same infrastructures. So when it comes to encryption, it is very essential to minimize risk. Now, if we encrypt things and so we give away our decryption key, guess what? We're going to be broken into. So how we store these keys is going to be critical to reducing risk in our environment. So let's talk about the levels of protections and the things we need to consider. The encryption keys need at least as much security as the data they protect. Let's talk about this. So if you've got $1 billion asset that you're securing, the new formula for a new drug, and you take the encryption key and you put the encryption key in an environment where it costs $50 to break into, guess what? Somebody's going to pay the $50 and steal your $1 billion asset. So the level of protection for our encryption keys need to be equal, if not greater, to whatever we're protecting. Because otherwise, you get the decryption key and you've got access, and it doesn't matter what else we've done to protect it along the way. The sensitivity of the data itself will determine the degree of data protection that's necessary. So, not going to spend $1 billion to protect photos of my cat, Cindy the cat. But I might spend $1 billion to protect a $10 billion blockbuster drug. Or the plans for the next NVIDIA H500 or something like that that's 3 times faster than what we have now, or 4 times faster. That we'd be spending lots of money to protect. To a degree, the effectiveness of our crypto system is going to be dependent upon keeping our keys secure and undisclosed. Except for public keys that we may use in asymmetric encryption. Everything else is going to have to be really secure. So we have keys. Now, how do we distribute them? So if I encrypt something on the way to Mark, and I give Mark the decryption key, I encrypt it. It's encrypted the whole way. He decrypts it. How do I get that key to Mark? If I send the key via email, and email is plain text, we've got a problem, right? So when it deals with keys, we have to think about how do we distribute them. We can create them locally and upload them to a certain key type environment and service, like a key management service. But whatever we do, we need to find some form of way to distribute the keys. In some cases, it could be me calling Mark. Mark, 129er Victor Golf Hotel 67 Zulu November. And having somebody copy it back and repeat it back to you on the other end of the line in a secure room. In another way, we could upload it and use it, but there's got to be some way to get it in a very precision sort of manner. I even remember calling out-of-band keys many years ago. Now, if we're going to issue a key, if I issue Mark a key, and then all of a sudden I don't want Mark to have the information, I need to be able to revoke that decryption key. So, we want to revoke access when we absolutely can. So, we have to be able to suspend the key or the user's ability to use it. And keys are going to be marked as revoked or become invalid. So how can this be implemented? Well, it can be centralized and it can be done via manual actions. It can be done based upon the key usage, distribution, what have you. Talk a little bit briefly about key escrows. And some of this has to degree with where the keys are going to be held. Now, there are times where we need to put it in a third party, or we put it in a third party, and there's a key escrow company, and they have certain security grades that they promise to have, and we trust them, and we have them hold our keys. They hold other people's keys as well. If something happens to our business goes burning down, our keys are still secure. Of course, if they get hacked, then we lose our keys. So there's always a trade-off that we have to actually consider. So think about that. When it comes to workstations, for the most part, Windows workstations typically have BitLocker and are typically escrowed for decryption if needed. And it's fairly common in cloud environments for incident response or legal holds to actually use a key escrow. Now, how long should a key be good? If I put out a key that's good forever, and somebody gets access to that key, they have access to me forever. If I put out a key that's good for a minute, great. The key's good for a minute. People can do less than 1 minute of damage to me. Of course, if I have to exchange keys or have a system exchanging keys for me automatically one time a minute, it may or may not scale. What if I have that doing that with 300,000 users at the same time? So a part of your key design is the key lifetime and determining when those keys will be replaced, etc. So you may choose to outsource your key management. So whatever you do, and I know I said it before, I'm going to say it again, do not store your keys inside of the data. And don't let anybody just access your keys. The only people that should get access to be able to get to the environment, they're basically what we're talking about, need access. They need to be authorized personnel only. So when we think about outsourcing key management, there's a couple of environments, especially if we outsource it to the cloud provider. The cloud customer can retain the key. And in this particular case, the organization itself manages their own keys. They're highly sophisticated at managing their own keys. And maybe it even goes in a third party. This, by the way, is the most secure option an organization has. Outsource this kind of key management outside of the cloud provider. What do you think the architectural trade-off with this is? Customer maintains and manages all the keys. Well, most secure, it adds more work to the end customer. And some of the benefits that people get out of the cloud is having some of this stuff pre-made and silly easy. So if you need the kind of security where you're going to manage your own keys, you're going to be reducing some of the simplicity and elegance you're getting from the cloud. Truth be told, anytime you need to create a high security or high availability environment in the cloud, like super high availability across multiple clouds, you tend to reduce many of those benefits as well. So let's talk about other ways we can handle some outsourced IAM, cloud access security brokers. So some of them can do key management as well. And typically speaking, it's more cost effective than doing it by an organization themselves. And when we're dealing with these cloud access security brokers, some of them are really good at what they do. So Zscaler is an excellent example. NetSpoke is an excellent example. McAfee has an enterprise system as well. I'm not very familiar with it compared to the other two. Could be great. But, you know, we've got a market here that's pretty dynamic, and there's a lot of players in this space, in these asymmetric encryption places, encryption ways, and ways to store and manage keys and cryptography. So kind of think about it that way. Lots of good options. Mark or Chris, before I get into certificates, which is part of this, how long has it been since I last stopped us? It's time. Okay, let's see if there's any questions, and then we will get back to the content, but let's answer questions.
All right, let's take a look and see what we have available now. From Kennedy, he's wondering, could you please, in the case of potential threats, that vulnerability exploitation, what are the indicators of compromise to watch out for? In that regards, Kennedy, there's a lot of things that you would have to take in consideration. When we're talking about vulnerabilities, number one is you would have to take an inventory of what type of software you have to begin with. Generally speaking, we're talking about software. Then we're going to look at the software and what it is running on, generally speaking, some type of hardware. And that hardware as well is going to have some underlying versions numbers, control numbers that we would have to keep in mind. The indicators, though, for compromise could be multiple. I'm going to give you just a couple of them, just to keep them in mind. It's not necessarily a full discussion in the context of the CCSP, but just to give you a little bit of an idea. If you notice, for example, a lot of unauthorized access attempts, that means somebody's trying to perhaps force their way into a system in attempt to kind of take advantage of a vulnerability. The other things that you might notice is, and this is where this monitoring idea comes in, that either you're going to have a SIEM system that's going to have also an orchestration as well as a response system built into it, and it's going to look at either some type of digital hash. So those are, think of them, they're basically characteristics of a particular attack. So that can go against a particular piece of software, could be go against some type of server attack, could be going to a specific piece of code that it's trying to take advantage of, this vulnerability. Then you also have behavior type of detection when it comes to security. This is now where you're going to take a look and see when somebody's in your system, and based on the role, based on the software that they have access to, are they behaving within particular parameters? And if not, so think about like a baseline, then perhaps that could be somebody trying to take advantage of our systems. So again, you'll need the monitoring in that with as well. Then we have what we call anomaly detection. So this is basically part of a security system that's going to take into context, based on reference material, what my baseline is. So what does my system normally look like? And anything that falls away from that baseline, how my system is supposed to actually function, that I'm going to have to inspect further. Now, if you add machine learning to that, what you could also do is you can take reference points from other entities that perhaps have, let's say, opened the same document as you. And there you might find out that 70 million other people, they opened the document, it didn't do anything too crazy. So it is within specs of doing so. But again, the biggest thing with these things is going to be, you're going to need continuous monitoring. You're going to have people that do some type of audit. Then you're going to have to do threat modeling. And eventually there has to be some kind of incident response plan. So that's kind of shrugged a lot of security architecture within about 3-4 minutes. From Scooby, he's wondering, metadata standards change according to who? Architect's proposal for upgrade. Does this happen? And if so, is this where the business acumen is useful? And what business courses are optimal for focusing so that you can hedge or career hedge?
So I think we've got 5 different questions related to 5 different related things inside of the same question. So here's why I bet you can't do the job without business acumen. And I'll skip the rest of it. If you're an architect and your whole job is to enhance an organization's business, and the tools that you have are tuning the way that people do their jobs, the individual business processes and technology, and your goal is to optimize business, but you don't know business, how do you do that? How do you design a new workflow? How do you determine how you're going to increase sales? How do you help that organization reduce the operational expenditure? How do you get enhanced productivity out of the employee? How do you look at that organization's capital structure with that organization to determine whether to build a private cloud, whether to finance that cloud, whether to go to a public cloud? How do you help that organization calculate downtime and its impact on the business? And in a business, what systems do they need to get operational during it? For example, what are the critical parts of that business? What are the not critical parts? How do you go to that business and sell them a $500 million architecture if you can't talk about how that business is going to work for them? So the job is 100% impossible without knowledge of business acumen. And that's why the people that have the most business acumen typically earn several $100,000 more per year than their traditional architects without it. And that's why you can see salaries in tech with business acumen, like a senior director at Palo Alto or a senior director at Cisco. They all pay over $500,000 a year. You'll see that same thing involved in the principal architect salary at most of these companies, because it's about your ability to optimize business. I can talk much more about that actually on the How to Get Your First Cloud Job webinar, but that's not related to the metadata. So I wanted to at least ask the main component of your question.
Question from Cloudy. Could you please expand a little bit on the concept of escrow? Cloudy, I'm not sure exactly how much you want us to expand on. It's actually a very small section within the CCSP. But the simple idea behind an escrow is that you're offloading part of the key storage to a third party. And generally speaking, that third party also is going to have to be really upping their security to be able to store your keys. Where I can expand a little bit on it is the thinking, would you want to use such a thing, such an escrow service? And the reason you should be really asking yourself that question is, even though you might be encrypting the encryption and decryption keys and then sending them over, which is always good practice, the question is, do you want to make your threat surface or your attack surface larger than it potentially has to be? But that's probably a question that I would ask myself. I would talk to the stakeholders. I would even talk to the escrow service. This will be part of my discovery when talking to them and trying to see what their rebuttal would be to my concern in regards to me increasing the attack surface. And then I would go back and I would make sure that all of this is going to be aligning with some type of business use case, because there has to be a really good reason as to why I might want to do that. And then through my risk analysis that I'm going to do with the rest of my team, because I need a lot of data input, then that might be a consideration in regards to would something like an escrow service to store my keys be advantageous to an organization.
Yeah.
Yeah. And question from Willie. He's wondering, can multiple keys be created and assigned to have more granular control of who can continue to access data? The simple answer is yes. The more complicated answer is going to be, how would you implement that directly? If you're going to be using multiple keys, you're going to need some type of control plane, some type of brains that can keep track of all the different keys. Now, it is not unusual, for example, if you have, let's say, a software-defined networking system that is going to be using an overlap of its encryption keys. So that way, it's going to provide one key at one time, and then before the original key expires, it will generate a new key and send that forward. But there's going to be some overlap in these keys that you can use. In a zero trust architecture, if you wanted to use encryption keys in conjunction with your digital certificates in regards to either to device posture or some type of authentication or authorization decision-making that your trust engine would do, then you can use those in conjunction with more granular policies in regards to what they can access. But I want to caution you with this, Willie. With anything, it is always good to keep it as simple as you can. The more complexity you add into your system, you need somebody eventually who can manage that. Now, we could make the argument, well, I have machines to do it. Well, machines cost money, just as much as people cost money. So besides complexity, now we have to factor in cost. But yes, it is definitely a feasible suggestion that you've made, and you can do it, but it does come at great cost. Okay, we're going to do a few more questions, and then we're going to get back to the content. So let us take a look and see what our next question is. Hello, sir. Mike, could you please explain cybersecurity as a career path?
So, yes, I'm going to give you two things. One is I'm going to invite you to the webinar tomorrow, because we'll be able to get much deeper in that webinar and we can speak face to face. But just understand, cybersecurity is like anything else. There are great career options. There's typically about 4 options in cybersecurity. Option 1, which is what I do, which is what I typically teach, which is the highest paying of these careers, is the cloud security architect or the security architect who designs the security systems. Option 2 is the defensive security engineer. The defensive security engineer builds the systems that are designed for the security architects like me. They also operate them and they also performance tune them. They're defensive engineers. The next type of engineers are offensive engineers, also referred to as ethical hackers, and they're trained to hack or break into systems and then tell the client how they broke into the system so the security architects like me can figure out how to secure it for the future. The last option is more of that technician role, and that's either going to be the person that configures the firewalls or the person that does a vulnerability scan by using some software and telling a target system and then sending the reports to one of the engineers to do something about it. So basically 4 options: designer, architect, engineer, either the people that break in or the people that defend against the break-ins, cops and criminals, if you will, and then the technicians that do a lot of the work. Hope that kind of helps. But join us tomorrow on the webinar. We can get much deeper on anything you want to know.
All right, fantastic. All right, let's take a look at what other questions everyone had. All right, Scooby, I have to ask, you must have an engineering background with these type of questions that are coming in. So I think that's akin of your key encapsulation mechanism question that you had the other day. But in either case, you're asking, are ASICs, which are application-centric integrated circuits, so specific chipsets that are built for a specific purpose, getting more popular in cloud-based encryption processes? And should we be familiar with them and the hashing designs? So I'm going to answer it this way first. Are they getting more popular? Yes. Are they anything new? No. In traditional networking, if you want to call it that way, many times we would have purpose-built line cards. So basically, they're like modules with ports on them that we would plug in, and they would have specific these security builds on them. And we generally got them so that we can offload the encryption and the decryption processes to them instead of having them done in software, and that's eating up CPU cycles on the router or the firewall. So that's where it's not a new process. Now, of course, with cloud, number one, yes, then we're getting more popular, but we also need to figure out how we're going to virtualize this, and then how can we share it across the different tenants. So from that perspective, when it comes to the CCSP, you don't have to be very familiar with the particulars of ASICs. You don't have to be super familiar in regards to if Amazon is using these specific chip builds, not for decryption or encryption. But in either case, I think the further down the line you go, and especially the higher you go in your career, knowing the options available to you is going to be the key there. All right. And Mike, if you're okay with that, so that we can keep on track.
Yeah, I am. You know, it's the funny thing is, outside of cryptocurrency, the better the CPUs are actually getting, the less we're using ASICs. And that's because we used to have our switches and routers that use more and more ASICs. And as CPUs got better, that was the beginning of the less ASICs around there, and software-defined switches and routers as opposed to that. So the next one will be the last one.
Let's take a look at that one. In terms of storing less in a database, more security, does that apply to the database size overall, or just the number of entities and records? And have you ever had to evaluate security implications of storing blob data in databases versus storing links to blob data stored outside of databases? I'm no sheer person when it comes to databases, so I will be deferring that question to Mike eventually. But the last piece is, in terms of storing less in databases, more security, does it apply to this overall size of the database or just the number of entities? You have any take on this? Have you ever done any type of evaluation like that before, Mike?
Well, here's what they're actually saying. The more data that you store, the more, if your data is compromised, the more damage it could be to you. So that's really the concept. It's like putting all your money in one stock. If something happens to that stock, it's theirs. So kind of think of it that way. Don't put too much stuff. Don't store too much stuff. And if you do, make sure it's highly, highly, highly restricted. And as far as Alan Hughes's question, the architect is the exact opposite of the analyst. The analyst is the technician that kind of does the everyday thing and generates a report that's given to other people. The architect is the designer. So architect designs, engineer builds, analyst kind of collects information to give to the engineers so the engineers and architects can do their job better. Hope that helps.
Okay, fantastic. Before we go on back to the content, if everybody can give us another hashtag, make sure you put hashtag CCSP into the chat box. Again, it gives us an ability to take your heartbeat as well if we want to go back to the health analogy in that. And before I forget, because I do forget this stuff sometimes, if you are new to the session, you join us for the first time, or you just haven't done so yet for some reason, download the free study guide that you will find the link to either in the chat box or as well as in the description box below the YouTube video. That's going to also give you the ability to not just listen to us via audio and watch us via video, but also have an additional stimuli of being able to look through the material as you follow along, as Mike weaves and webs his way through the information to help you understand the different concepts and the theories on how they work, what they are, and how you can actually practically apply them. And I want to give great questions.
Yeah, keep up the great questions, and I want to give you all a secret. The harder the exam you prepare for, the harder the thing you study for, the more you realize, oh my God, there's so much to learn. So I didn't realize how much I didn't know until I finished my CCA, and they said, Mike, here's your first big project. And I went, oh, I guess I'm a beginner and I'm going to start. So as we get into bigger and bigger certifications, you may realize, well, these things are a lot bigger. That's a good thing, because no one can know all of these things. There's various architects. There's some people that focus just on IAM, and some people that focus on breaking into systems, and people like me that focus on designing it at the business level. And there's people that design things at the more technical level. There's lots of options. So these bigger things will make you realize how big the world actually is. So if you come away with more questions, that's okay. And now you have the book, and you can go deeper and deeper and deeper things, and this is how we grow. So let's talk about certificate management. And why are we using certificates? The whole point is to identify individuals and to identify systems. And we need to make sure that people and systems are who they claim to be. So maybe if we think about it this way. So if I think I'm talking to Mark, but I'm not really talking to Mark, and I'm talking to Nick, who's pretending to be Mark, and in this case, Nick is not a good guy, well, that's a problem. And potentially, I could think I'm talking to Mark, but Nick could be pretending to be Mark, and I could be talking to Nick and not Mark, and that could be a man in the middle attack. So we always have to know where our endpoints actually are. Are they who they're supposed to be? So certificates can help us in a lot of ways to identify end systems and people, what have you. And in cloud computing, where we don't have these hard to find boundaries that we can actually create, and these network segmentations that we can't create anywhere close to the degree, endpoint verification becomes even more important, although it's always important. Now, when we're dealing with certificates, realistically speaking, we can be there's going to be public and private keys, because we're going to be using some asymmetric encryption in the way these things are exchanged. And the certificates themselves can either be self-generated, or they can be generated by a certificate authority. So there's lots of certificate authorities that are out there that can help you with this, including the cloud providers are also certificate authorities. So a certificate authority will provide a certificate repository for storage and distribution. The certificate repositories will have you the ability to create what's called a certificate revocation list. So if I have a conversation along the line and I'm sharing keys with Aguilo, and he and I have exchanged keys, but all of a sudden Aguilo does something that I'm no longer happy with, I can just pull that certificate. I can create a certificate revocation list, and that would stop the communication in the future. So if Aguilo's certificate was taken or compromised, I could also cancel it. So it helped protect us with certificates. So there's a life cycle to a certificate. It's going to be created. We're going to manage it. It has to be discovered. And then it's either going to expire or we're going to revoke it. So data has a cycle. Certificates have a cycle. Everything has a cycle here. Now, when it comes to certificate management, we have to think about some security practices here. And any certificate management practices we have should be kind of similar to our encryption key management practices, because it's really one of the same kind of thing. We're going to have some secure storage of our private keys to the certificates somehow. We're going to have to understand the process to revoke certificates if we need to, if there's a breach, for example. We're going to have to plan for some life cycle management of these related to the creation, the distribution, and the ownership profile of the data we're talking about. So there's that. Now let's talk about hashing. Hashing, to me, is like the coolest thing in the world. I don't understand the math behind it. My wife does, but I don't. She's great with math. But to me, it's the coolest thing that with a hash, we can take one input, generate a consistent output every single time, but you can't go from that output back to the original thing. So if I enter the letter A in the system with a 256-bit hash, I will get a 256 character thing that comes out. Every time I enter A, I will get the same characters that come out. Here's the cool thing. I can't go back from those 256 characters back to the age. To me, that's just wizardry. It's math wizardry, and I'm not a mathematician, but I think it's cool. So why do we use hashing? Well, we use it to make sure things don't change. You send a Zelle to somebody for $1,000. It's got a hash value. If the $1,000 was changed to $10,000 that you Zelle by accident when you really wanted to send 1,000 because it was broken along the way, the hash would become invalid. If the hash becomes invalid, the transaction won't go through. So that's why we're using hashing. The hash makes sure that the data hasn't been changed along the way. So when we're using encryption, we're typically using some form of hashing. So if I am using IPsec, for example, and I identify Mark as who Mark claims to be in the end, so we don't have a man-in-the-middle attack, and then I send a sequence number of my packets, packet 1, packet 2, packet 3, if you will, we can make sure that every packet got to the end. And at the same time, if I send a hash at my data, Mark can be sure that the data I sent him is actually real. So that's where we use hashes. So other times you may use hashing in security. If you were going to download a DVD of the newest Red Hat operating system, or CentOS, or Ubuntu, or anything you want, when you get your download, you can verify that download across the hash and make sure that you're getting the legitimate copy and it's not been hacked along the way. So kind of keep that in the back of your mind. Now, normally speaking, the output of the hash is much smaller than the input, because it's just going to be a number, a signature based upon the data. So they're one-way functions and they can't be decrypted. One way in that you get this gibberish on the outside that you can verify, but you can't go from the gibberish back to the original stuff. So let's talk about other ways we can actually deal with data. So we can obfuscate data. Obfuscating is making things harder to understand. We see it a lot. People ask someone a question on the news, and they give you a 50-word answer that doesn't answer anything related. They've obfuscated the answer. It's terrifying, honestly, if you pay attention. But it's one of the ways we can protect our data is we can obfuscate it. We can make it hard to see. We can mask the data. We can take the data and sort of anomalize it and pull out identifiable information from the data. We can take the data and create tokens out of the data so that the tokens have a lower level of information than the actual data itself, and we're exchanging tokens. So first you need to know the token, have access to the token, and be able to figure out how to go back to the data. So there's opportunities that we have. So one thing that we can do is we can use a randomization process. So we can take our data and we can add random information to the data. So every string has the same length and same character set, so it looks really realistic. That's one thing we can do. We can anonymize the data. So I've got a huge data list of customers, right? I remove their names, addresses, and phone numbers. So now I still have the data, but I don't know whose data it actually is. I can also do some kind of pseudo-anonymization, but here I remove some data, but leave some potentially de-identifying information. So maybe I have an address or a zip code or an age. I've got something. So think of it this way. Randomization, you replace the data with random stuff in various places. Anonymization, you typically remove the name, address, phone number, something that's really easily identifiable. And pseudo-anonymization is kind of that hybrid midpoint where you keep some of the data but remove some other parts of the data. Another way we can send we can use is hashing here, because we're sending a one-way cryptographic hash of the actual data. And realistically speaking, we can make sure that the data is unrecoverable, but the ability to reference it and go back to that same data is actually there, and the data hasn't been modified. We can also shuffle the data, and basically we can have a data set and we can move certain things around the data set to change the way we represent that data. And in this case, it's going to actually create realistic test data, because we can take real production data, we can flip some stuff around where we still have the same information in the data set, but it looks completely different than the source. And we can use that as good data to run tests and simulations. Another opportunity with data and protecting data is something called masking. You've probably seen this. So it hides some of the characters, so you can't see it. So if you log into an account, for example, here's an example of masking, and you see the last 4 digits of your credit card number, and everything else is masked, that's masking, because they can't do anything with the last 4 digits of your credit card number. But it at least shows that you are you. And this is basically where you give partial data, but you don't reveal sensitive information. Excuse me just 1 second. Sorry, I'm slightly allergic to cats, and by slightly, I mean heavily. And I have a cat that sleeps on me every night over here, so it is what it is. All right, so another thing we can do is a technique called nulls. And that's where we take raw data and we delete certain data and we show it as zeros or nulls. So we're reducing our data set functionality, but we're increasing our data security. And that goes back to the more stuff you have in your data, the more stuff that can be used against you. That doesn't mean you shouldn't have good data practices and have data. It just means think about it and plan it accordingly. So a little more about tokenization. So let's say we've got data. It could be Cindy the cat's data. 3 bonkers per pops before breakfast on October 30th. Had 2 bonkers per pops, the tuna variety, after lunch at a certain time. And I'm sure by the time I am done this thing, she will walk me to the cat lollipop collection and make me feed her tuna pops. So I could keep track of that data. And maybe I would get rid of the per pops and replace it with an LL for a lollipop or something simple like that. But that's realistically speaking what we're talking about. We're just taking something and replacing it with something. It's a token, it's a value, but it's keeping things there. And the token themselves not going to be a direct hash, but the key here is they're trying to avoid direct hash attacks here. And because you can actually hack into a token, statistically speaking, there's ways, but it's very hard to do for the most part. So the point is we're trying to create an obscured copy or dynamic, something that's dynamic, that's going to go, it's going to change, and it's not going to be usable again. So there's different ways that we can implement tokenization. We can do it in a static sort of environment, or we've got a representational data set which is created, and it's used as a copy from the original, and the data is obscured during access. That's one option that we typically have. Whenever we think about masking, obfuscation, anonymization, or tokenization, we always have to think about the security considerations, because sensitive data in many cases can be derived from mundane elements of data. We may not think it is, but you can usually find there's patterns of data that some people can find even if we don't see it. If we anonymize information, in many cases we remove specific things that are there. Interestingly enough, if we're not careful with AI, AI can collect the data after we've anonymized it and reconstitute the data in some cases. So with AI and data security, we have to be careful of that, actually. And anytime we mark data as sensitive, we're creating additional metadata. So if we're marking data and labeling it as data and labeling it as sensitive, which we need to do, generally speaking, in order to protect our data, guess what? Now it says to the hacker, most important stuff on it. So there's that. So maybe, just maybe, we mark it sensitive, but mark it with another term that we've created for ourselves, some obfuscated meaning. So we do that instead. We come up with a new one. So instead of it being critical, maybe we call it a lion. And that way lion means critical sensitive data for us. I'm on a cat kick. I just like cats too much. So a little bit more about tokenization. We're using basically two different databases. Typically speaking, one with the data and one actually with the tokens. So what'll happen is the token server will authenticate to the user or the program. It'll retrieve the token. It'll map it to the actual data, and then it will actually present it. And this is going to add a level of security and reduce dependencies on encryption. But in order to make this work, you've got to have some very strong authentication protocols for the token server, because you don't want to be giving the wrong person access to the wrong token server. Briefly, with regards to data loss prevention, the point of data loss prevention is to protect data from leaving the organization, especially during the share phase. And we need to be fairly flexible of the use of data and where the data is going to be, because it might be on-premise, it might be on somebody's mobile phone, it could be in the cloud environment. So we have to be flexible where the data is, and now we've got a bigger attack surface. And as it pertains to security controls, we're adding just more layers of defensive strategies. We're trying to mitigate the accidental data misuse or intentional data misuse. We want to have a policy which we can actually enforce. So if a user's trying to copy data or take data that they're not supposed to, we want to let them know that, hey, you're not supposed to do this. And first, most people do things unintentionally by accident. Secondly, we want to remind you, don't do this. But if someone's doing it, we told them not to do it, and they do it anyway, it makes it much easier for the employer to remove that person from the organization, for example. Or yank that person's access, or criminally prosecute that person if they're actually stealing sensitive data that can be used to endanger others potentially. So with these types of controls, we should be able to see it. We should be able to see data being encrypted as it leaves, and what's going on. We should be able to see where our data is actually going. Most data loss prevention tools, one of the goals of them is monitoring. It's a log stream, monitoring what's going on. And when it comes to a regulatory compliance perspective, it's going to identify and control the information, the data types, and seeing is it adhering to the mandates that we've placed in place. And if there's regulatory mandates on our data, and we've set our DLP systems to help us meet these regulatory compliances, and if we don't, we get fined or prosecuted or what have you, these systems can help us a lot here. So data loss prevention systems can help us with controlled data using tagging or pattern matching or similar techniques. They can monitor activity involving data or files that match a certain thing, and enforces, organizations' patterns. So let's talk about what pattern matching is. And typically these things are typically done via machine learning of some kind. So pattern matching is there's a normal set of behaviors that we all take. My iPhone, and I don't know how it does it, it knows what time I'm going to practice yoga, whether I tell it time or not. Because for many years I went to the same yoga studio at the same time every day. My phone would literally give me directions. Are you sure you're going to Native Yoga in Juno Beach, Florida? Every day. Every Sunday it knows I go to Native Yoga. And it tells me where I'm going. It recognizes a pattern. And pattern matching techniques are widely used in both anomaly detection and data loss prevention. The example I like to use with regards to pattern matching is when I joined Cisco, most days I was in New Jersey, maybe I was in England, or I was in Florida. I didn't travel that much more than that. So what happened when I joined Cisco, and one day I went from Palm Beach, Florida, to Washington, D.C., to San Jose, to London, to Dubai, to Melbourne, to Hong Kong, and back to Dubai, my credit card got shut off along the way because the bank didn't think that was my normal pattern of behavior. It actually was for years, and they got used to it, and they never matched it as an anomaly. So data loss prevention systems, many security systems use these types of anomaly potentials, and they're looking for patterns and matching patterns and looking for what's normal and looking for what's not normal. So how are these data loss prevention systems dealing with IDs? So identification. So they can be manual, automated, manual, or both. For the most part, these things often will look at your storage volumes and your production environments, and they will use data and matching data. So they'll look for numerical strings, or things that could be like social security numbers, or things that could be like an ICD-9 or ICD-10 code, like a diagnosis code. And it'll look for stuff. And it will use some form of a categorization, or it'll give you a classification marking or a label or metadata from that create phase. It's going to give you something if your data was labeled there. And it'll help you look for keyword searches to see if sensitive identification is highlighted in data that's actually stored. Many of these can also be used for monitoring egress traffic. So on the way to the cloud, for example, or away from your systems out to the internet, these things can be there, and they can be monitoring systems. And they can process data in the production environment. Many of these systems put a little user agent on the desktop, which reports back to this master server, but there's lots of ways. But the key is it's monitoring what's going on. And by monitoring what exits, a lot of times we can prevent data from being lost. So how do we enforce it? How do these data loss prevention systems actually work? Well, in one case, they can alert people. You get a message that says, hey, somebody's breaking a rule. The user themselves may get a warning, a big screaming thing, banners which pop up, or something that's saying you're doing something you're not supposed to. Are you sure this isn't a mistake? If so, stop it now. The penalties for releasing this are X, Y, and Z. The key here is to prevent unauthorized actions, sending sensitive attachments, and it could actually lock users out of their account after their accounts have been doing something like this. So it's designed to catch it and hopefully help find it. Of course, you can't rely on one system catching everything. You'll need backup systems and other systems to monitor things as well. So when it comes to the challenges, you can't actually go look at the cloud provider's data center. So we have less things that we can do here. So now data loss prevention systems become much more important. And they're going to be doing a lot of monitoring, especially in the cloud environment, and that monitoring can get pretty expensive. A little bit about log capture and analysis. So every system we have has logs. Logs, logs, logs. And if you've got a Linux machine, I think is it in var/logs? I'm not sure, but there's logs that you can look at. I haven't been an engineer for about 25 years, so, and architects, we don't really get into log files. But you've got logs on your Linux machine, which goes on days and days and days and days and days. My Mac, I think it makes like 100 log things per message per hour. My firewalls in my house have logs which go off constantly. My routers and switches in my house have logs which go off constantly. There's just so many things. My VMware servers generate these large logs. My OpenStack cloud generates all these logs. Now, you got a business. They've got 50,000 servers, you got a lot of logs. 5,000 routers, you got a lot of logs. And if you look carefully in the logs and you know what to look for, you'll be able to find so many things. Thank you, var log. I thought that's what was in there somewhere. And I guess app is your application logs. So if you really think about the number of these logs, so the goal here is to see what's going on. And one log in itself may mean nothing, but the collection of logs is no big deal. So what am I talking about by aggregating logs? So lots of things can look like an anomaly, but might be okay. So if I walked into a 7-Eleven and said hi to someone and took a box of Twinkies and walked out the door, that wouldn't be a normal thing. The people in the store might say something to me. The police might get a description of a guy that's about 6'2", that's about 220 pounds, that's got a certain build. Now, it could be me. Somebody else could also look like me. But if it's me, and now I'm carrying a box of Twinkies, now I look more like me. So the point is we're using logs to correlate one thing and two thing and three thing and four thing and five things. And if when I went into that 7-Eleven and took a box of Twinkies, not only did I have the box of Twinkies with me, but if I was wearing a red shirt that said Cindy the Cat on it, now all of a sudden they'd have me wearing the same red shirt, Cindy the Cat. They'd have me with the box of Twinkies, and they'd have the description. Each time it gets a little better, and that's the same thing with logs. We may see something that looks a little questionable over here on the firewall, but we don't notice it. We get another log over here, a couple of missed logins from the system over here. Ooh, this is starting to look interesting. Now we see some transaction logs over here. Here's what actually happened. And that's the point of capturing these logs and analyzing these logs. So these logs are going to be generated like crazy. But when we can correlate the logs, that's where we're referring to. And what are we correlating? Somebody made one change on a router and it took this down. Somebody put an access list in one spot. That access list blocked the interior gateway protocol on that network and it took the whole thing down. Somebody made a BGP error and the next thing you realize half of the company is now no longer able to access the internet or reach any of its things. So it's those things that you're looking at from a how do I fix stuff that we accidentally broke perspective, but it's also about finding the hackers and catching the hackers. By the way, I don't eat Twinkies. I don't eat sugar or anything like that. And I would never steal Twinkies, but I wanted to try to show the correlation of a whole bunch of things to put it together to try and make it make sense. I do eat a lot of broccoli and a lot of fish and a lot of fruit, though. So there's tools that can help us monitor these logs, analyze these logs. And that's typically what SIEM systems do, which we'll talk about a bit later. But I want you to understand we have to evaluate these logging capabilities we have and the costs associated with them and the limitations appropriate with every tool, because there's going to be a lot of tools to do this. And there is no best tool. The best tool for us is going to be the one that best needs our clients' needs with our unique client specifics. So what are the kind of sources that could send us some information? And so let's talk about where these log entities are going to come from. So our identity systems, our directory systems. And after we talk a little bit about this, we'll go back to a break because I know we're getting into some complicated things. So an identity system or directory system determines who you are, what you're allowed to do, and keeps track of it. So if I log into Active Directory a couple times too funny, it should send off some logs. What if I try to access something from the wrong IP address? Maybe that generates a log. Another thing that typically comes from these type of logs is typically the IP address and an event. So we can usually find out what part of the world it's happening from the IP address. And we're typically going to get a timestamp. When is this thing actually coming? So a little more about the kind of attributes we're going to get from these various types of events. Could be things like a service log, an event ID, a query, or the number of requests that are processed. I will have to do some form of a security the security will have the ability to do some form of security analysis because our admins and our analysts are going to be monitoring these systems and looking for these logs or looking for these malicious events. We're going to get logs specific from the cloud providers itself. And we're also going to have to think about the kind of logs we want. The kind of logs we want to alert from, where we're going to store these logs, the tools that we use to analyze these logs, what the retention period of our logs are, and the security measures. So figuring that out, that's going to take some time. Your architects are going to be speaking with management for a long period of time to kind of figure these out. My team has suggested that it's been about 20 minutes, and we have lots more log stuff to get, and some of the log stuff can get a little geeky, so I think we probably should stop for a few minutes and see if there's any questions.
Alrighty, let's take a look and see what fun questions everybody has had so far. Oh, sorry, 1 second, guys. I had something pop up I should not have. Okay, question from It's Just X. This is a broad question. But based on the information you provided and your experience, what is the best combination to achieve data protection?
It's just us. The best combination to do anything is to find your customer, understand their customer's unique needs, understand your customer's business challenges, understand your workflows, understand your organization's current technology platforms, the structure of everything they've done, and understand the logic of why, and then make a determination. If we ever write the prescription as a physician or a nurse practitioner before we've diagnosed the patient, the chances are we will hurt our patients. If we ever, as a surgeon recommends a surgery without seeing the patient, they're going to be harming the patient. And in tech, if we ever have a planned best way to do something without actually know the needs, we are going to hurt the client because every different challenge requires a different solution. So that's what I've learned, is never to make these mistakes. Now, I've seen people over the years try to use a pre-made cookie cutter approach, and sadly, 70 to 80% of technology projects provide zero business value. Zero. And that's because people are trying to put a system in place without even knowing what problems they're trying to solve. So I hope that didn't come out rough, but that's what I've learned after all these years.
Yeah. Also, It's Just X. It's really a lot of the pieces that we've already discussed and that we're still going to be discussing. So in regards to what so far we've discussed, of course, there's going to be encryption, data at rest, data in transit, the key management systems that we've discussed. We're going to get more in depth, of course, with access control, such as identity access management. As well, we mentioned earlier a question also in regards to least privilege, right? You only get access to what you should have access to, nothing more. So there's going to be those things. But like Mike said, really, you need to understand what the business use case is going to be. Since one solution or one size doesn't fit all sizes, so to say. So that's really, unfortunately, going to be the answer here. All right, let's take a look at our next question. And this one is from Scooby. He's wondering, as an architect, should we familiarize ourselves with the attack vectors becoming more common, such as those that are pre-built into more and more popular hacks, such as building built into Kali OS, for example?
Okay, Scooby Dow, if you think that's cybersecurity architecture, you're completely missing it with a completely different kind of career. Join us tomorrow on the How to Become a Cloud Architect webinar, and we'll go over the architecture careers and what we really do. As an architect, if you're working with an enterprise, first thing you need to know, there's probably going to be 10 cybersecurity to 50 cybersecurity architects in that enterprise. There's probably going to be 100 plus security engineers working on that enterprise, and there's going to be a legal team. You will need to think about everything as the security architect. So quantifying these organizational security risks, speaking with the executives, learning the workflows, meeting with stakeholders across that business and learning that business. That's 25 to 30% of your time right there. And you'll always be doing that. The next thing you need to be doing is building your architecture team, leading your architecture team, having the person that's responsible for networking security work with you, the person that's responsible for application security working with you, your storage people working with you, your big data working people with you, because it'll be impossible for you to learn all these things at a level that's necessary to ever do this. You're going to be concerned about risk mitigation techniques. You're going to be concerned with writing a policy. That policy will deal with incident management, who speaks to the press, who actually comes in, who does what in one process. You're going to be building business continuity and disaster recovery plans. You're going to be giving presentations to various stakeholders, presentations, executive briefings, presentations at conferences. You're going to be documenting architectural roadmaps. You're going to be documenting and facilitating meetings. You're going to be looking at all this stuff. You're not even going to be able to think that deep like an engineer. And that's why when people wonder if they've got an engineering background, will it help them? It often hurts you because you're focused on just these things. You got to focus on everything. So that means you're focused on developing training programs for the people, anti-phishing, anti-malware. You're focusing on building a business case to show the value in this, to make this work. You're busy determining their end-to-end encryption strategy. You're determining their vendor partnerships, their vendor relationships, their key escrow, their key management techniques. You got to lead a team of 10 people for this entire thing throughout your architecture and design. And your security architecture could take you 12 months. So understanding attack vectors, yeah, absolutely. But it's not like an engineering job. 50 to 80% of this job is not technical. And you're not going to be able to design it all yourself ever. It's going to be so big that you're going to need a team of people. So much more about figuring out which area you know. For example, network security is my area. Any kind of layer 2, layer 3 security, that's where I've spent most of my life. There are other people that just focus on IAM and they're architects for just IAM. There are architects that just focus on zero trust. And together, when we're going to design these things, it's going to take a team of people. So your ability to create the team, lead the team, manage the team, understand these risks, understand it from a business perspective, and then to go convince people to go spend millions of dollars on your stuff. That's the job. So best job, really is.
And then part of that question was in regards to strategies and organization posturing is in our domain. Scooby, let me kind of tie that back into what Mike sort of said so that everybody also gets an understanding. Because I can definitely understand where you're coming from. I can visualize that, where you're trying to dissect things to try to make more sense to you. But when it comes to anything security related, when we're talking architecture, I want you to always consider the mindset of keeping it high level. And what I mean with that is, instead of knowing the specific tools and techniques on how somebody took advantage of a vulnerability to get into your system, or if they did some type of cross-site scripting attack against a server and then had that kind of bounced off to another server to kind of do the attack, you really just want to understand the principle behind the attack. And that way that you can eventually focus on the overall system design and the security controls. That's really where you're going to come in. Mm-hmm. Now, if you wanted a practical application, let's say you are in the role of a security architect and you became familiarized with, let's say, a vulnerability. In this case, let's say there's issues with a particular version of Kali Linux. And you now want to figure out that since it's going to be a vulnerability, you want your detection systems to actually be able to detect them. As Mike mentioned earlier, you're going to have your general digital signatures. That's part of your hash of what makes up the attack. You can have behavioral type of monitoring, and you can have anomalies. But any type that you can, to get to doing any of that, the first thing that you will have to do is what we call in the profession is threat modeling. You will actually have to create a map of the different attacks and the point in which they might attack. And then look at what systems you, at the moment, and this goes into what we call heat mapping, you do have available and you don't have available. And then you go through a scenario of how that roughly will play out. And in which stage of that threat modeling are you either going to just do some type of detection, you're going to do some monitoring, or if you're going to do some type of response to it. But in any case, once you go through this type of threat modeling to figure out, okay, is there some operating system or kernel type of security vulnerability you need to consider? You start building a response plan. That's your incident response management plans. We call them in the trade playbooks, because this is going to be eventually how you're going to act on these things. But all of this, what you're doing here is strategizing and planning. And then eventually that also has to be communicated back to the stakeholders. And then you would disseminate that information, of course, to the engineers that can make sure that the various security systems that you have in place, assuming that you're not using anything such, let's say, a zero trust framework or anything, but you're doing traditional defense in depth, right? The layering of different modules and capabilities. Then that's what you would do. So you say 3D chess as its best. We call it's a cat and mouse game. That's really what it always is. By the time you figure out a vulnerability and how to protect against it, the mouse already tries to figure out another way how to get into, or get to the cheese, so to say. But that's what you're doing as an architect. It's all about strategizing. How do you build out a strategy on how to deal with something, and then how do you communicate that to the team so that you can do the implementation aspects of it? Besides that, you're not there. You're not on hands-on when it comes to this. You don't have to know the nitty-gritty details. You're not a penetration tester. You're also not a security engineer that you have to worry about those type of details. Okay, let's see if we have any more questions, Mike.
Yeah, so I think we have one or two.
Okay, so from Caleb. Okay, let's take a look at it. So Caleb is wondering, when we are studying and learning, how do we know, or where do we draw the line to know when we are going too deep or too technical on a topic versus understanding I'm assuming he just meant understanding.
So,
okay.
Yeah, I'm going to give you an. Yeah, what's that? What'd you say? What'd you say, Mark?
Go ahead and answer that first.
I'm going to give you this one, and Mark is going to add to this. So, Caleb, it depends on the career you want, and if you're an architect thinking about it. So, I'll give you the difference. I'm going to give you the engineer depth, and then I'm going to give you the architect depth, and then I'll give you the engineer depth. Architect depth. I have two direct connections to AWS. How do I load share across both of them without getting out of order packets, meaning going out one link, coming back another? Okay. I can span a specific subnet on one link and an aggregate on that link, and a different specific subnet on the other link and an aggregate. I could change the weight of the routes. I could change the local preference of the routes. I could change the origin code of the routes. I could change the multi-exit discriminator of the routes. These are my architectural options. That's architecture. Now, I'll give you an engineering. In OSPF, we have link state advertisements, which are sent from all the links which are going to describe the state of everything. We have a type 1 link, which is generated by the router. It is sent to the multicast address 224.0.0.5. All routers generate this. Now, we also have a type 2 LSA in OSPF, which is generated by the designated router. By the way, on a multi-access LAN segment, we now have to generate a primary and a backup router that will provide the routing updates for the subnet. So type 2 LSAs are generated by the designated router on a broadcast multi-access segment. Now, as we leave our area, we generate a type 3 LSA, which is generated by area border routers, which are routers that are both in area 0 and other areas outside of this. Now, as it pertains to more, let's talk about the Type 4 LSA, which teaches us how to find a router that connects us to an autonomous system domain. So we have a Type 4 LSA, which describes autonomous system border reachability. Now, of course, if we're going to take a route out of something like EIGRP and redistribute it, that will be an OSPF external route. Now, we can make it a type 1 external route, which means that from every hop it will continue to add a metric, or a type 2 external route where the metric won't change. And that will be an OE2 route versus an OE1. That's engineering depth. If you're going down that deep and you want to be an architect, you've gotten way too geeky and way too technical. The first one, I gave you something that was fairly simple, and elegant. That's how you can tell. If you're an architect and your focus isn't on the business 80% of the time, you're actually hurting your client because they hired you to help their business and you're focused on their tech. That's how you determine it. So always, what is the business implications of what you choose? And the second you have a technology that you love, that you fall in love with, that you want to go to somewhere, you're no longer an architect. You lost your trusted advisor. Caleb, I hope that helps. And I'll have Mark do it, but I wanted to try to give you the difference between engineer depth, and I got really geeky on that engineer because it was necessary to be able to do that, to do the job. And the architect, here's my option 1, option 2, option 3.
And since you added to it, Caleb, you said architect. So I was going to tell you, it depends on what type of role you want to go after. So in case of an architect or any type of role, you first want to map out what is entailed in being competent at that position. So we know for a fact, if we're talking engineering, we do have to know what the technology is. We want to have a good understanding of how does that technology work, because we'll need to do the implementation of a technology. So Mike used the example of OSPF, the routing protocol. So I would have to know how I implement, meaning I go to the CLI, I type in router OSPF and then my process ID, and then I go through the JAS. I'll have to know how to do that. Okay. And then I will have to understand, how does this protocol work when everything is okay? And how does the protocol look like when it's not okay? Meaning you'll need troubleshooting skills. When a system is broken, do you know enough about the system to be able to fix it? Mm-hmm. The architect does not need to know how to go into the router and how to fix it. He does not need to go in there, like Mike mentioned, at the packet level, do a capture on the wire, and be able to look at the link state database exchanges, have to know the actual finite state machine, or it's the link state, the interface state machine, I believe it's actually called. He doesn't have to know that. But for example, the architect will need to know when there is a need to add areas to an OSPF design. And that generally is done because of either a particular business requirement from the get-go, or perhaps either you or perhaps somebody else, they didn't account for growth in the beginning, which, by the way, is a big, big no-no if you've never done that. But let's say you did. That's where the architect or the designer will come in, because he'll know exactly on how and why I would be expanding the areas and what would be the best way of doing so. He will not have to go into the CLI again. He will not have to define the area. He will not have to define the authentication. I say he loosely, right? It's he, she, depending on who it is. But that person does not necessarily need to know all the minutia of the databases and the link state advertisements. When it comes to your learning, this is where it gets a little bit tricky. Because even as we're going through this, you're going to be put into some kind of bubble in regards to what is covered on the examination, what is not covered on the examination. But even with that, what we recommend to everybody is enjoy the journey of learning. What that entails, though, is that sometimes for some, that means, you know what, I'll have to do a little bit additional research on the topic. Maybe I don't necessarily understand, how encryption works. Or give me a better idea. Besides just, I want to keep prying eyes away from it. I don't want people stealing my data. Why else would I use encryptions? What are my benefits? What are my disadvantages? So you're comparing and contrasting. That's the important part. Comparing and contrasting benefits against disadvantages or negatives. So that's one of those things. You may have to do that to make that your own. Others may have to say, you know what? I hear you, Mike. I really do. I do get encryption. I still don't understand really how it works. Maybe you're one of those people then that needs to fire up, let's say, virtual devices, either firewalls, routers, whichever one has the capability, and as well as the extra cryptography licenses on it. And you might say, you know what? I'm gonna pop up a VPN. Once I have the VPN, I have reachability. I'll need to create that IPsec tunnel because I want to be able to get a little bit nitty gritty. I want to add the encryption. I want to see what is possible. I need to do that packet capture just to make it your own, to visualize it. Maybe that's it. But here's the key. that is for your learning,
Yes.
for your understanding. For that, go as deep as is required for you to learn, understand, and eventually be able to communicate a particular technology, particular solution, because you'll be talking to people and recommending them solutions based on a business need. But aside from that, if you wanted to go like Mike myself did the CCA route, if that's what helps you get it done to understand it, knock yourself out, do it. But that's not going to be part of what gets the job done. So there's going to be a delineation between the two. I know a little bit long-winded, but I hope that gives you somewhat of an idea how deep you should or should not go. Right. Let's take a look. I'm not sure. Do we have any more questions? I believe we have.
I'm going to answer one. We
More?
always need to be humble. But no matter what, if people don't respect us or believe in us, we are done in our careers. So it would be totally fine if Mark is the chief information officer and he asked me, are you comfortable with this? For me to say, well, I've never seen a situation like this. However, I've dealt with this situation, and this situation, and I'd never seen a situation like that either. And I delivered this billion-dollar architecture with a degree of success that was exceptional in this one and this one. So I'm sure with enough time and building the right team, we can build the right plan to make you successful. And if I can't guarantee that you'll be successful, we'll tell you that in the plan as well. That's totally appropriate to do. But you still have to have the ability to command respect. And the ability, in most cases, most of the architectures that I've done in my life were things that no one's ever done before. And it's like, okay, Mike, you go figure this out. And I was like, well, okay, so what did I do? I started finding teams of the smartest people I knew in environments and said, okay, I've done this with a bank, not this, but you've done similar things with a bank. What's been your experience? And you build your fundamentals and you learn how everything works at that underlying level. Not how to configure it, but how everything works. And then you take one big problem, break it into many small problems, and then you're good to go and you'll always know where to begin as long as your fundamentals are good. The key is that level of fundamentals. All right, let's get back to the content. But if you haven't liked the video, please give it a like, subscribe to our channel, hit the bell to be notified of new things. Tomorrow, we have a free webinar on architect stuff, and it's on Zoom. We do one almost every Thursday, but this one will be in an earlier hour because we've got this in the afternoon, which I'm having fun with teaching all this stuff. So join us there as well. I spend lots of people there. It should be a good, fun time. So let's talk a little bit about log management. So I really want you to understand the sheer volume of these logs that we're actually talking about. And how much space these can actually take over time. So imagine a log file. At one point, so my first tech job was a senior engineer at MCI WorldCom, and as soon as I passed the CCA, I got hired as a network architect at this company called Knight Securities. They were the largest market maker on the NASDAQ, and they were doing billions of trades per day. Each trade, logs. Imagine that all going through these systems. So you've got all these servers, all these routers, all these switches. You are going to get a tremendous number of logs. So where we store these logs, we have to think about. In the data center, storage is cheap. It doesn't cost anything. It's practically free. In the cloud, things get expensive fast, especially as it pertains to storage. So we have to be more methodical about where we're storing our data. To put it into context, I picked up a 96 terabyte network attached storage, 1,000 megabit a second throughput. It was about $5,000. It's about $300 to $500 for that same amount of storage in the cloud. So $5,000 one time versus $3,500 a month every month for, say, 4 years. You can do the math. One cost is obviously a lot cheaper. So now we're on the cloud, and now we've got logs, and now storage is expensive compared to the data center. So that means log storage gets expensive. So we need to be careful about what we're using. What are we protecting? And that means we need to have this management decision of how long do we keep our logs? How long do we preserve them? Which logs do we need to preserve? And what security measures do we need to do? Because A lot of hacks come from inside the organization and its business. Lots of them. So if they're coming from inside the business and the person can steal something and then delete the log, well, that didn't protect us from anything, did it? So we're going to need tools to help us. And in the world of log management, the tools we're going to be dealing with are SIEM systems, which are security, information, and event management systems. And they are going to take these logs and they're going to help us manage these logs. So, security, information, event management systems, what they are designed is to collect logs, analyze the logs for you, typically speaking with AI or some form of AI or machine learning, manage these logs, and display it to you. So, you may hear them called security information management, security event management, or security information and event management. SIEM is typically what they're referred to as SIEM. So the goals of good SIEM systems are to centralize our logs in one place. Take the logs from AWS, Azure, and Google and log it in one system so you can see what's actually going on. Because it's aggregating it from all your sources, your operating, your workstations, your servers, your network devices, your IoT devices, your security devices, your storage devices, your everything. Now you've got access to a lot of great information. Now you've got a machine that can use AI that can find things that you're not supposed to find, which is really great. These SIEM goals can, as we get into bigger and bigger SIEM systems, now we've got a system that has access to too much information, right? So now we're going to need even a greater set of security controls over the SIEM systems, because if I allow someone that doesn't need great access to highly sensitive logs, well, guess what? Now I've reduced my security. So from this architecture perspective, it's all these little things going on in all these different places, which is why architects are considered orchestrators. We're kind of determine what to do and where to do versus playing the musician, much more like the conductor in the orchestra. So the point of the SIEM system is to do repetitive tasks for us, to constantly run, constantly search, provide some good threat detection out of a very large data set, and kind of keep that. Now, automated tools aren't perfect. They may miss low and slow attacks or persistent threats that come over time. So we still need people. We still need analysis. So when it comes to SIEM systems, we're typically going to have a dashboard. And the dashboard will offer a graphical output for displays, and it'll make it fairly easy to visualize and display information, and it will help the staff identify things that are typically missing. Now, some SIEM systems actually can automatically respond. So they can develop a pattern recognition, a pattern of behavior, and then they can respond accordingly. Okay, we are now approaching a very different topic. So I wonder. So it is 4:43 p.m. Let's get into cloud security. So the first thing we want to talk about is when we deal with the cloud is this concept of the shared risk, shared platform. And we'll get into much more cloud security tomorrow. Shared responsibilities. So in my data center, it's easy. I'm in control of it all. It's easy, right? Now in the cloud provider is managing their network, right? And so the cloud provider manages their network. The cloud provider is managing their underlying servers and their underlying hypervisors. The cloud provider is managing the underlying storage infrastructure. You have no control over that. So you have to trust that they're doing theirs right, but you are going to be responsible for your systems on the cloud. So the thing that we want to think about is you are responsible for a lot of different situations differently than you would be in the data center. So let's talk about breaches. When someone accesses your information, who's responsible? You are. So you're in the cloud provider. The cloud provider makes an error. Who is responsible? You are. So understand that. Now, so you break some law because something's exposed by the cloud provider. They may actually come after you. And you may be able to sue that cloud provider, but ultimately you are responsible. So one of the scary things of cloud computing is you're responsible for your data, and you don't have complete and ultimate control of your data. That doesn't mean we shouldn't use cloud computing, but at least think about this. So let's think about that and the repercussions for the customer. If we are in the cloud provider does something, and we get hacked and our information is compromised, we can get negative publicity. We can have the loss of trust for us as a business. We can lose market share. We can have our stock value tank, have our insurance go up because somebody else made a mistake. So it's not just financial liability that we have to be concerned of when we go to the cloud. I like to say this: if you were crazy enough to design a hospital in a single cloud, a hospital that did surgery 24 hours a day and had a trauma center, and then that cloud went down and people died in the hospital, sure, your service level agreement will be like, okay, here, we'll give you some money back. But if people died in that hospital, there's no recovering it. What's the fix? A hybrid cloud. Have a data center at cloud. Cloud goes down, who cares? Put your systems into 2 clouds. One cloud goes down, who cares? So critical systems, you don't put them in one cloud, you don't have this problem. But understand from a data perspective that if you're in a cloud and they breach something and they do something, you're still legally responsible for it. Because the customer is the ultimate person responsible. So if you're a part of a company and there is a data breach, you have to tell people about it. So generally speaking, when there's a data breach, you're going to negotiate it in your contract with the cloud provider, and they will talk about who's responsible for what, who's your contact number to actually speak to. There's typically some diagrams that'll tell you in an emergency do X, Y, Z, that kind of thing. Kind of hope that's helpful. Now, when there is a breach, you got to understand there's going to be conflicting interests here. So I don't know how many of you worked in a multi-vendor environment. You got a router made by one company, a router made by another company, and they're connecting via BGP, or everything should work. Company A's router doesn't work. They blame Company B. Company B blames Company A. So kind of think that these kind of things I just want you to actually think about. So there's a liability here. Remember, the cloud provider always focuses on their stuff, and you focus on your stuff. So your objectives as a customer are typically to have maximum control over your data, maximum administrative power, maximum insight to see what's going on, maximum set into your logs, and maximum information and performance. You can't get that in the cloud. So just understand that. That's one of the things you give up. Does that mean the cloud's not good? No, it doesn't mean that at all. It means after evaluating all trade-offs, if the cloud is the right way to go, we go with the cloud. But the legal liability that we have to be very careful here. The provider or the cloud provider's objectives are this: to protect people from sensitive data, to restrict access to as much as they can to protect hacking of their systems, to have very strong security controls in place and very strong procedures and very good monitoring. And they may not even tell you where their data centers are if it's highly secure, because if I tell you that my super security data center is on 123 Main Street and you're an attacker, you're going to go break into 123 Main Street. But if I've got a super mission critical data center at the bottom of the ocean or in the middle of the desert somewhere and you don't know about it, it may actually be more secure. And the cloud providers may do that, or businesses may do that as well. Of course, now you've got to consider what are the challenges of being somewhere in the middle of nowhere where there's nothing getting power or getting cooling. So it's all trade-offs. Now, the key here is in legal liability, Now we've got an adversarial relationship going on here because we've got the cloud provider who's responsible for themselves. You've got you who's responsible for yourselves. And then there's the people that are going after the company who are responsible for themselves. So there's going to be an adversarial dynamic that's going on in all of these negotiations. So we can't really get heavily involved in negotiation here like we do in our cloud architect training because we have 1,000 hours there. But to make it clear, both parties are going to have to clearly understand their goals and needs and strategies ahead of time. The providers here are typically advantaged because they've got a lot of knowledge of their data center operations. They have very deep pockets and they have a lot of money. So, they've got the legal team that most businesses can't afford. Enterprises may, but most businesses cannot afford. So if you're trying to deal with planning and negotiations with a cloud provider as a small business or as a newer business, you're going to need some good lawyers that are going to be fairly expensive if you need to do that for business purposes, specifically around security breaches. Tomorrow, we're going to begin by cloud computing risks by deployment model, and we'll have all kinds of fun by going over private clouds and community clouds and hybrid clouds and all this other good stuff. So I want to begin there, but I want to give you a few minutes for questions before we leave for the day. I can, then tomorrow we'll get involved in more stuff. So let's see what questions did pop up.
All right. I hope everybody had a fun time so far. If you do have any more questions, we'll entertain them for about 10 minutes. So if we can stay on track. All right. So there is. It says another broad question. This is fun. It's just X. How would you prioritize responsibilities of the CCSP for a big company and a middle one or for a nonprofit one?
I'm going to start that with a question that we can come back with. What job would you mean the CCSP is a certification? So, reply back. Are you referring to a cloud security architect? Are you referring to a cloud security engineer in a defensive role? Are you referring to a penetration tester? Or are you referring to a security technician or admin? Because that will change everything. It's the difference between a physician's day, an airplane pilot's day, a lawyer's day, and a teacher's day. So I'd love to answer it, but we can't answer that until we know the other part of the question that you're referring to.
The one thing I can tell you is just X responsibilities, even as an architect, they will vary depending on the organization you're in. I give you a little tidbit while we wait for your answer. Like, for example, I've been in situations where we would have to communicate with the customer, figure out what are the business pain points, what are they trying to accomplish, what outcome do they want. Then I found myself in other situations where once you create that end-to-end system, so in my case, it was networking, that you become so intimately familiar with why you chose one piece compared to the other piece, that modularity, that I even got called into troubleshooting calls. Now, I wasn't the one actually performing the troubleshooting, but I was like the second set of eyes, translating between the customer and the engineer, bringing a different perspective to these things. So you might find yourself having multiple different responsibilities. It looks like he said the role is cloud security architect.
Okay, so now we can get in there. So if you're in a big company, understand your cloud security team may be 300 people large. So if you're working in a big company, you can either be one of the more executive architects like me, where you focus much more on the business side of the architecture and you spend much more time with the C-suite, and your day involves team meetings and entertaining clients and facilitating discussions and presenting at conferences and presenting at briefings. That could be your entire job. And that's going to be your highest paid of all these jobs. That's going to be your $500,000-$600,000 a year architect job. Now, you might have another architect job where you've got a security architect in a big company, because you're going to have lots of different architects. And some of these architects are going to be technical. You might have a network security architect that's an expert on network security, things like demilitarized zone design, and layer 2 security and layer 3 security and IDS, IPS systems and that sort of thing. You may have a security architect that's got expertise in application security and how to lock that down. You may also have an architect, a security architect whose focus is identity and access management strategies. You'll have tens, if not 50s, if not hundreds of engineers that are going to be on your team with you that will be able to test things for you. And that's going to be in a big company. Now in the middle one, maybe 1 or 2 or 3 architects. And now you got a small number of architects, which means now in this particular situation, most likely you're not going to be as strategic in doing as many things with the business. And these smaller businesses typically don't use technology as much as a competitive strategy. Now, if they do, your role is going to be equally as defined as it is if it's in a big company. And here, your goal is to be strategic about the technology. You may have 2 or 3 architects, and you're going to be building your team out of the other people. You're going to be building team out of some people from the networking team and some people from the data team, and you're going to be working with those because you're still going to need their various forms of expertise. Now you go to a small non-for-profit one. They don't need you as an architect anyway. They need 2 or 3 people. So whatever they hire is going to be an engineer. They may call it an architect, but it'll be an engineer. It'll typically be very low pay, and it'll be hands-on, build stuff. Maybe you do a little design, maybe you do a little build. It's not strategic, it's not anything, and it's very engineering-oriented. So what really determines what your role is not necessarily the size of the company, but how strategic technology is to the business. Some businesses like Walmart, for example, have found ways to be so efficient with technology they were able to be better, faster, and cheaper than their competitor. They have major architecture practices. There are other companies that haven't figured out how to use technology. They don't typically have good, strong architecture practices, and as such, they typically don't have real architects working for them. But then again, they're the companies that are typically reporting financial losses that you don't want to work for anyway because they're not going to be able to pay you anything, and even if you did, they'd be laying people off on a routine basis. So you want to work for a company that's strategic about technology if you want to be an architect.
All right, question from Scooby. He's wondering, is there general things as a cloud security architect that we must know, like sumo logic to feed log info to AI? So to answer your question there is, number one, if you can use a SIEM system, such as Sumo Logic, and it can integrate into the different cloud platforms that you use in the services, so if you're multi-cloud, then definitely that is something that you should be familiar with. But just like we mentioned before, the only reason that would be of interest to you, think of high level, is how you can come up with strategies once you've been able to ingest the information into your SIEM system. And then also, just to give you an idea, we say SIEM, S-I-E-M, Security Information Event Management System, as an umbrella term. What you'll also have is what we call SOAR systems. So this is the Security Orchestration and Automation Response Systems. And they're also going to be plugging in the Endpoint Detection Response Systems. When you plug all these 3 things together, actually what you get is an extended detection and response system, which you can not just look at endpoints anymore, you cannot just collect logs from different platforms, but it's an inclusive system that can also look at cloud analytics when it comes to the virtual routers, the virtual entities, your virtual machines, and it can also go into your data center and also pull information from those systems as well. So in that sense, you should be aware of it because you're eventually going to take all these and they're going to allow you, number one, to perform your threat modeling, your heat mapping, as we call it. And then also something that you want to keep in mind when it comes to all of that, you're going to have to be running risk analysis. So that's going to be your risk management strategies that you have to come with. So it's definitely one of those tools. And with AI, there of course come other things from a security perspective that we'll eventually have to keep in mind, but it's not something that is touched on in depth when it comes to the CCSP.
Yes, and I'm going to give you 2 sides of this, especially because job descriptions out there are the most meaningless things you're ever going to see as it pertains to architects. Scooby, you're smart, but I have a feeling you're an engineer, and I have a feeling you're trying to engineer your architect career, but looking for little engineering tidbits. Let me talk about some of the things we're actually going to be doing as architects. And then if I talk about these, then I'll go back to what CIO Magazine says. So you will be creating technology roadmaps that are going to be aligned with an organization's business objectives. You're going to be analyzing their current technology systems and their infrastructure. You're going to be identifying for areas of improvement, both in their technology, but their people and their business processes. You'll be designing future state architecture models. You'll be developing IT governance models, policies, and procedures. You're going to collaborate with stakeholders across various parts of the enterprise to get an understanding of the business requirement. You're going to be collaborating with vendors from various vendors, and there can be a lot of vendors you deal with to kind of work with the right solution. You're going to be managing security architecture documentation and creating gap analysis between the current state and the to-be future architectures. You're going to be overseeing systems integration efforts as it turns between these various systems. You're going to be enforcing architecture standards and best practices. You're going to be assessing IT mitigated risks, optimizes resource allocations and then architecture review boards and leading them. And I could go on, but notice what none of them said. Tech. And, there's a huge misunderstanding between what people think architects do. And no place is more funny when you see the biggest joke in the world, which is a cloud architect job description, which looks like an engineer's job, which is never accurate. In fact, it's so bad that Gartner actually went out there and asked the chief information officers when he wanted an architect. And I'll tell you what they wanted in an architect, because I've been an architect for 25 years, but here's what the CIOs say. I want someone that can lead the cultural change for a cloud adoption. That's a lot of stakeholder management. That's a lot of schmoozing. That's the ability to exercise influence and sell. They say, I want someone that can develop and coordinate a cloud architecture. That's leading that architecture team that we're talking about, which means having the business acumen, the executive presence, the leadership skills, the emotional intelligence to do it. They talk about developing a cloud strategy and coordinate the adoption process. Okay, we're going to go hybrid multi-cloud for this reason. Step 1, step 2, step 3, step 4, that's what it's going to take. And then they say, what else do you want your architects to do every day? And they say, find talent with the necessary skills. This is why I've interviewed 6,000 people in the last 25 years for jobs. Assess application, software, and hardware. Create a cloud broker team. That's the team of people that are going to be involved in these things we're talking about. Establishing best practices for the cloud across the company. Overseeing governance and mitigating risk. Okay, which are the people responsible? Who are involved in change? Who needs to be spoken to? Who are all the key stakeholders? When can changes occur? So working with security people to develop privacy, monitor privacy, develop incident response procedures. That's who speaks to what in the event of an incident. Manage budgets and estimate cost and operate at scale. Wait. You didn't hear code, you didn't hear configure, you didn't hear DevOps, you didn't hear sumo logic, you didn't hear any of that. So I think you're trying to add an engineering flavor to the architect job. This is a business executive job, and it pays like a business executive. So where people go wrong is they try to turn themselves into engineer. They try to memorize every little detail in the engineering thing. And here's the reality. Let's pretend you're on a security architect interview. How would you design your demilitarized zone for web access, for remote access, for an organization that has mission critical security requirements and 250,000 people and 1,000 applications that are in seven different continents? Could you compare and contrast the benefits of the Palo Alto firewall versus the Cisco firewall in our unique use case? Should we use one set of next generation firewalls or two next generation firewalls? What are the strategic advantages of using a Palo Alto or a Checkpoint or a Cisco firewall over as an AWS WAF? What are those long-term implications as it pertains to our environment? What type of policies and procedures do we need in place from the time someone creates a user from an identity strategy? What type of a policy do we need that kind of guides things? So every time you go tech, remind yourself that's engineering. This is planning. This is strategy. So I love that you're getting geeky with this tech. I absolutely love it. Thankfully, here's the good news. When you're an architect, the company's going to have engineers, and you're going to work hand in hand with those engineers because they are the best at building this technology. They know the technology better. We are there as architects to map the business problems to a technology strategy. Those engineers are so smart. And we are so lucky to have them, and they are so tech-oriented. So If Mark's my network engineer and I'm the network architect, I'm going to approach it with Mark. Okay, Mark, I've got a situation and I would like to do this. Can you go figure out the details? Mark will go figure out the details and he'll get back to me. Mark, is this crazy idea of mine going to work? Mark, you know the engineers in this company. Are they sophisticated enough to carry this out? And you can get geeky with them. Meanwhile, I'm speaking to the chief information officer, the chief information security officer, the CEO to find out the vision of the business, and I'm trying to work with that chief financial officer to get him to be willing to buy our stuff on time and to prove there's business value. So kind of hope this makes sense. So I'll get into a lot more depth on that webinar tomorrow, but I really want to kind of make that make sense to people. This is a very business-oriented job, and that's why people get hurt when they try to prepare these things. They do all these practice projects and all these engineering labs, and then someone asks them to calculate an ROI, and they go, where? Or they ask, when was the last time you responded to an RFI, RFP, RFQ? Which is the kind of stuff we teach people to do because that's what architects do. I hope that helps.
Yeah. Let me add this too, because we can kind of transition my thought of it also into the questions that Willie and Nigel had, and something that we can do about it tomorrow. For you, Scooby, first is, as I told you in the chat, it's a mindset. I want everybody to understand when we say mindset, we're not talking perspective. Mindset, we're talking about a way of thinking that has to be different. So in this case, an architect, the way they think is going to influence their approach. That approach and that thinking will be different than somebody who has the technical depth and how they're going to approach it. Because in their mind, they're going to have requirements that they need to get done compared to what the architect's requirements are or prioritizations. So that's what I want everybody to keep in mind. You need to develop a different way of thinking about a particular problem. Instead of the technology piece first, you want to think about the people and the processes first. The technology, believe it or not, as an architect, is on the lower rank of priorities. There's much more important things that first need to be addressed before we can ever think about what, fun technology, once we do the unboxing of the routers and the switches and the load balancers that comes always last. It's the mindset itself, that thinking.
Yes.
And when it comes to Willie and Nigel, you guys have had some fantastic questions, but in regards to job descriptions, we love talking about those, and as well as certifications and how do they fit into this role. I would encourage both of you, if you have not done so, and of course, those that are interested in learning about the answers to those questions as well, look in the description box. If not, I already see it in the chat box. There's a link for tomorrow's webinar. We're going to have it a little bit before the actual bootcamp starts. There, we're going to be discussing the different skills and also characteristics of what it takes to be an architect. And we'll touch a little bit more on specific, also cloud architecture. We will have some different architectures into it. But that particular webinar, we're going to have a lot more time to be a lot more detailed in our response. And something else, in case we haven't mentioned it before, the nice thing about the Zoom session is going to be, if you want to, you can come off mute. You can use your microphone. We can have a conversation and see how we can map out potentially what it is that you're trying to accomplish and what the right path might be for you. Aside from that, Mike, do you have any additional comments?
No, I really, it's what happens is the architect role it's a great role. I love the role. It's just so misconfused. Probably, and it was never misconfused before. What happened is AWS and Azure, they came up with the term solution architect for a certification that had no solution architecture in it. It had all systems administration training, and that's confused so many people. But we'll go tomorrow. We'll get real on the role. We'll get specific on the role, and we will give you everything that you need. So I look forward to seeing you in the morning. It'll be a lot of fun. It'll be on Zoom. You've got questions. We can give you the correct diagnosis, tell you what you need to do, tell you exactly what you are. You put on a couple of interviews and it's not working out and we'll tell you why. We'll be able to assess you just like that and be able to help you when we really want to help you. So join us tomorrow, completely free. We'll see you on the webinar. We can continue the conversation. And tomorrow afternoon, back at 2 p.m., we will be back and we will be having more fun with the CCSP training, the CCSP Certification Bootcamp, which I'm having a whole lot of fun. We got people from in pretty much every country in the world you could possibly think of. So we will see you tomorrow. Give me a hashtag CCSP if you're able to. If you haven't liked the video, give it a like, subscribe, hit the bell to be notified of new videos, and I'll see you tomorrow. We got 5 hours of free stuff going on tomorrow, so look forward to seeing so many of you.